Welcome back to Tech with Shaping Pixel. If you're preparing for the Microsoft Azure AZ-104 certification, you're in the right place. In this complete crash course, we'll cover everything you need to know to confidently pass the Azure Administrator exam. From managing Azure identities and governance to deploying virtual machines, configuring networking, implementing storage solutions, monitoring resources, and much more. We'll break down the key concepts in a simple and practical way. Whether you're a beginner starting your Azure journey or an IT professional looking to validate your cloud skills, this course is designed to help you learn faster and focus on the topics that matter most for the exam. Make sure to subscribe, hit the notification bell, and let's dive into the world of Microsoft Azure. This is Tech with Shaping Pixel, and let's get started with the AZ-104 full crash course.
Welcome to the Microsoft Azure Administrator Full Crash Course, designed to help you prepare for the AZ-104 exam or simply build your skills as an Azure administrator. The AZ-104 exam covers several essential areas. You'll need to know how to manage Azure identities and governance, implement and manage storage, deploy and manage compute resources, and configure virtual networking. Monitoring and maintaining Azure resources is also a key focus. Our course closely follows these published learning objectives, ensuring you're well prepared for every topic. You'll learn managing users, groups, and access, configuring storage accounts, deploying resources with ARM templates and bicep files, creating virtual machines, provisioning containers, securing networks, and performing monitoring, backup, and recovery. Let's get started on your Azure journey. Overview of Azure Services. This course offers a broad introduction to Microsoft Azure, focusing on the wide range of services it provides. Rather than diving deep into any single topic, you'll get a high-level understanding of what Azure can do for you or your organization. Who this course is for. Whether you are completely new to Azure or just curious about cloud computing, this course is designed for you. While no prior Azure experience is required, having some general technical knowledge will help, as basic terms like file server and operating system are not explained. Ready to explore Microsoft Azure? Let's begin. Microsoft Azure is a collection of online services that organizations use to build, host, and deliver applications, all without needing their own data centers. Everything runs in Microsoft's global data centers, accessible over the internet. Core services. Azure's main advantage is flexibility. You only pay for what you use, and you can scale resources up or down as needed. The three core elements for most applications are compute, storage, and networking. Compute powers your applications, storage keeps your data safe, and networking connects everything together. Compute options. Azure started with virtual machines, or VMs, which let you move existing applications to the cloud. Later, Microsoft introduced Azure App Service for hosting web and mobile apps without managing infrastructure. Containers, like those run with Azure Kubernetes Service, offer lightweight, scalable environments. Azure Functions provides serverless computing, so you only pay when your code runs. Storage solutions. Azure offers blob storage for files, Azure File Storage for shared folders, and data lake storage for analytics. For databases, there's Azure SQL Database and Cosmos DB for massive scalability. Networking basics. Azure's virtual networks, or VNets, connect resources securely. You can link VNets, use VPNs for encrypted connections, or ExpressRoute for dedicated high-speed links. Migrating your server application to the cloud with Microsoft Azure is straightforward. The easiest way to get started is through the Azure portal, which runs in your browser, so there is nothing to install. Setting up your virtual machine. To move your application, search for Virtual Machine in the Azure portal. Click Add to start creating your virtual machine, or VM. You will be prompted to select a subscription, which is a collection of Azure resources that share a bill. Next, create a resource group, which helps organize related resources. Name your VM and choose a region close to your users for better performance. Choosing options and security. Select an operating system image, such as Ubuntu or Windows Server. For cost savings, you can use an Azure Spot instance, but remember, it may shut down unexpectedly. Set up your administrator account, ideally with an SSH public key for security. Be cautious with inbound port rules. Avoid opening SSH to the entire internet unless just testing. After reviewing your settings, click Create. Once your VM is ready, you can manage it directly from the portal. When finished, delete the resource group to remove all associated resources and avoid ongoing charges. Creating a website with Azure App Service can be quick and efficient, especially if you use the command line instead of the portal. Let's walk through the process using Azure's Cloud Shell. Launching Cloud Shell. To start, look for the Cloud Shell icon next to the search bar in the Azure portal. Click it to launch a small virtual machine for running Azure commands. The first time you use Cloud Shell, you may be prompted to create a storage account. Just follow the prompts to set it up. Downloading sample website files. Cloud Shell supports both PowerShell and Bash, but we'll use Bash for its simplicity. Next, copy the git clone command from the GitHub repository linked in the course overview. Paste it into Cloud Shell to download the sample website files. Creating the web app. Change into the new directory using the cd command. Now, create your web app with a single command, AZ-web app up --location west US --name your unique app name --HTML. This tells Azure to deploy a static HTML website in the specified region. Testing and deleting the app. Once deployed, visit your app's URL to confirm it works. To avoid charges, delete the app by removing its resource group using AZ group delete-name. Alternative deployment methods. You can also deploy web apps directly from Visual Studio or Visual Studio Code, but management still happens through the portal or command line. Microsoft Azure offers a vast range of cloud services, far beyond just compute, storage, and networking. Let us highlight some key Azure services that help organizations modernize, innovate, and streamline their operations in the cloud. Migration and identity. If you are starting with Azure, Azure Migrate is your go-to tool. It discovers and assesses your on-premises servers, whether physical or virtual, and helps you plan and execute migrations. For identity management, Microsoft provides Entra ID, a managed identity service similar to Active Directory, making it easy to synchronize your on-premises directory with Azure. Developer and application services. For developers, Azure DevOps offers tools to automate building, testing, and deploying applications. Azure Pipelines enables continuous integration and delivery, while Azure DevTest Labs lets you create cost-controlled, non-production environments for testing and development. IoT and analytics. Azure IoT Central is a fully managed solution for connecting and managing Internet of Things devices. For big data analytics, services like Azure Databricks and Azure Synapse Analytics support powerful frameworks such as Apache Spark, making large-scale data analysis accessible and efficient. AI and integration. Azure AI services provide pre-built artificial intelligence tools for vision, language, and decision-making. For workflow automation, Azure Logic Apps and Azure Event Grid let you build complex, code-free integrations across Azure and third-party services. Introduction. Building an e-commerce solution on Microsoft Azure is all about combining the right services for a seamless customer experience. Let's walk through how you can create a concert ticketing platform using Azure. Core services. Start with Azure Apps Service to host your web app, making it easy for customers to browse and buy tickets. Store concert details in Azure SQL database and use Azure AI Search to help users quickly find events. For user accounts, Azure Active Directory Business to Consumer, or B2C, handles authentication for customers outside your organization. Orders are placed into Azure Queue Storage, ensuring reliability and scalability. Azure Functions process these orders, generate printable tickets, and store them in blob storage for easy access. Enhancing functionality. Allow customers to post concert reviews, which are queued and processed by Azure Functions, then stored in SQL database. To speed up searches, use Azure Cache for Redis. The Azure Content Delivery Network caches static files, making your site load faster for everyone. Performance and monitoring. Azure Traffic Manager directs users to the nearest web app instance, improving responsiveness. Application Insights monitors your app's health and provides analytics to help you understand user behavior. Cost considerations. With a medium setup for up to 100,000 users monthly, expect costs around $900 per month, depending on your chosen services and regions. Azure Monitoring and Alerts. Managing your Azure infrastructure means more than just building solutions. Azure Monitor is your central hub for tracking resource health, combining tools like Application Insights and Log Analytics. Its core features, metrics, and alerts help you visualize trends and get notified instantly if something needs your attention. Service Health and Backups. Stay informed with Service Health, which alerts you to Azure platform issues and upcoming maintenance. To protect your data, use built-in backup features for services like Cosmos DB or Azure Backup for virtual machines and even on-premises systems, ensuring you can recover from outages. Cost and security recommendations. Azure Advisor is your personal consultant, suggesting ways to boost performance, availability, and even reduce costs by identifying underutilized resources. For security, it pulls recommendations from Microsoft Defender for Cloud, formerly Azure Security Center, helping you address vulnerabilities across your environment. Compliance and policy management. Microsoft Defender for Cloud also shows your secure score and compliance with standards like the Azure Security Benchmark. Customize policies with Azure Policy, such as requiring all storage in the European Union, and monitor regulatory compliance with ease. Automation and governance. Automate resource deployment with Azure Resource Manager, or ARM, templates. For even greater control, use Azure Blueprints to deploy and audit entire environments, combining templates, policies, and permissions for streamlined governance. Introduction to Azure Storage. Let's explore the core storage services in Microsoft Azure, designed to meet virtually every modern data storage need. Azure offers a range of options, each tailored for specific scenarios, all underpinned by robust security and reliability. Key benefits of Azure Storage. Azure storage services are built for durability and high availability. With built-in redundancy, your data remains safe even if hardware fails. Data can be replicated across multiple data centers and regions, protecting against local failures or natural disasters. Automatic encryption ensures security, while fine-grained access controls let you manage who can access your data. Overview of core storage services. Azure Blob Storage provides scalable object storage for massive amounts of unstructured data like text and binary files. Azure Files delivers managed file shares accessible via the Server Message Block Protocol, supporting Windows, Linux, and macOS. Azure Queue Storage is designed for storing millions of messages, enabling communication between distributed application components. Azure Table Storage offers a schemaless NoSQL store for structured data, making it flexible for evolving business needs. Azure Managed Disks provide block-level storage for virtual machines with options like UltraDisks, premium solid-state drives, standard solid-state drives, and standard hard disk drives. Access and scalability. Azure Storage is massively scalable and accessible worldwide via HTTP or HTTPS with client libraries for .NET, Java, Python, and more. In summary, Azure's 5 core storage services deliver secure, scalable, and versatile solutions for all your data needs. A storage account in Microsoft Azure acts as a container for your data, hosting objects like blobs, files, queues, tables, and disks. Each storage account requires a unique name since your data is accessible globally across the Azure platform. General-purpose storage account types. There are 2 main general-purpose storage account types. The General Purpose Version 2, or V2, account is recommended by Microsoft for most scenarios, supporting blobs, files, queues, and tables. The General Purpose Version 1, or V1, account is a legacy option with similar features, but Microsoft suggests using V2 instead, as V1 may eventually be phased out. Specialized storage accounts. Block blob storage accounts are designed for premium performance with block and append blobs, making them ideal for high transaction rates and low latency needs. File storage accounts focus solely on files, offering high performance for enterprise or demanding applications. Blob storage accounts are legacy, blob-only options, but Microsoft now recommends using general-purpose V2 accounts instead. Key features and recommendations. All Azure storage account types use Storage Service Encryption, or SSE, for data at rest. Archive storage and blob-level tiering are only available for block blobs. Zone redundant storage and geo-zone redundant storage are limited to certain account types and regions. Introduction to Azure Blob Storage. Azure Blob Storage is Microsoft Azure's object storage solution designed for storing massive amounts of unstructured data. This includes everything from text files to binary data. It is highly scalable, making it ideal for organizations that need to manage large volumes of data efficiently. Key uses and access methods. You might use Azure Blob Storage to host images or documents for websites, stream video or audio, store log files, or keep backup and archive data. Accessing blob storage is flexible. You can use HTTP or HTTPS, the Azure Storage REST API, Azure PowerShell, the Azure Command Line interface, or client libraries for languages like Java, PHP, and .NET. Structure and organization. Blob storage is organized into 3 main resources: the storage account, containers, and blobs. The storage account provides a unique namespace in Azure. Containers, similar to directories, help organize blobs within the account. Each container can hold an unlimited number of blobs, and you can create as many containers as you need. Types of blobs. Azure supports 3 blob types: block blobs, append blobs, and page blobs. Block blobs store up to about 190.7 TB of data. Append blobs are optimized for logging, while page blobs are used for random access files, such as virtual hard disks for Azure virtual machines. What is Azure Files? Azure Files is a cloud-based service that provides fully managed file shares accessible through the Server Message Block Protocol, or SMB. This means you can access your files from anywhere, using Windows, Linux, or Mac OS machines. Key features and benefits. With Azure Files, organizations can mount file shares from both cloud and on-premises deployments. You can even use the Azure File Sync service to cache these shares on Windows servers close to your users, speeding up data access. Azure Files is often used to replace or supplement traditional on-premises file servers and network-attached storage devices. Thanks to support for Windows, Linux, and Mac OS, Azure Files can now fully replace older file server solutions. The addition of Azure Files Active Directory authentication allows permissions to be managed through on-premises Active Directory, making integration seamless. Use cases and management. Azure Files is especially useful when moving applications to the cloud, particularly those that require shared storage for application or user data. Since it is fully managed, you do not need to worry about hardware, operating system installation, or patching. Management is simple using PowerShell, Azure CLI, the Azure Portal, or Azure Storage Explorer. Azure Files is built for resilience, so you are protected from local outages and server upgrades. In the next lesson, you will learn how to create an Azure file share using the Azure Portal. Let us take a quick look at Azure Queues, a service designed to help distributed applications communicate efficiently. Azure Queues are not for sending emails, but for passing messages between different parts of an application. What is Azure Queue Storage? Azure Queue Storage is built to store large numbers of messages, making it ideal for distributed systems. These messages can be accessed from anywhere in the world, as long as you use authenticated calls over HTTP or HTTPS. This global accessibility ensures that different components of your application can communicate reliably, no matter where they are located. Key components of Azure Queues. The Azure Queue service is made up of several important parts. First, there's the URL format, which includes both the storage account name and the queue name. For example, a queue named Images to Process in a storage account called My Storage Account would have a specific URL. Next, the storage account acts as the main container for all your Azure storage services. The queue itself is simply a collection of messages, and remember, queue names must be all lowercase letters. How messages work in Azure Queues. Messages in Azure Queues can be up to 64 kilobytes in any format. These messages are used to enable communication between different components of distributed applications. Azure Queues provide a reliable way for distributed applications to communicate using simple messages stored and accessed securely in the cloud. Azure Table Storage is a cloud-based storage service from Microsoft designed for structured NoSQL data. Unlike traditional relational databases, it uses a schema list design, meaning your data does not have to fit a rigid structure or specific data types. Key features of Azure Table Storage. This flexibility makes Azure Table Storage ideal for storing large amounts of structured, non-relational data. Organizations often use it for user data in web applications, address books, or device information. It is especially useful when you need to store terabytes of data for web-scale applications that do not require complex joins or stored procedures. Components of Azure Table Storage. Azure Table Storage is made up of several key components. First, the storage account provides access to all Azure storage services. Within the storage account, you can create as many tables as needed. Each table is a collection of entities, which are similar to rows in a database. Entities consist of up to 252 name-value pair properties, plus 3 system properties: partition key, row key, and timestamp. Each entity can be up to 1 megabyte in size. Use cases and access. To access your data, use a unique URL that includes your storage account and table name. Azure Table Storage is perfect for scenarios requiring fast access to denormalized structured data at scale. Introduction to Azure Managed Disks. Azure Managed Disks are virtualized block-level storage volumes, similar to physical disks in on-premises servers, but fully managed by Microsoft Azure. They're designed for use with Azure virtual machines, making storage simple and reliable. Key benefits and scalability. Managed disks offer impressive reliability with 99.999% availability. Each disk has 3 replicas, protecting your data from up to 2 simultaneous failures. Azure supports up to 50,000 virtual machine disks of a specific type per region in each subscription, allowing you to scale easily. Integration with availability sets and availability zones ensures your applications are protected from both single points of failure and entire data center outages. Encryption options. There are 2 main encryption types for managed disks. Server-side encryption, or SSE, is enabled by default and secures your data at rest. Azure Disk Encryption, or ADE, encrypts both operating system and data disks using BitLocker for Windows and dmcrypt for Linux. Disk roles explained. Azure Managed Disks come in 3 roles: data disks for storing applications and files, OS disks for the virtual machine's operating system, and temporary disks for page or swap files. Remember, temporary disks are not managed disks and are not meant for important data. Azure Managed Disks simplify storage, enhance security, and scale with your needs, making them a powerful choice for your cloud infrastructure. Managing Azure storage can be simple or powerful, depending on your needs. Guy Hummel explains 2 main tools: Azure Storage Explorer for those who prefer a graphical interface, and AZ-Copy for command line enthusiasts. Let's see how each one works and which might be right for you. Using Azure Storage Explorer. Azure Storage Explorer is a free application for Windows, Mac OS, and Linux. Download it from Microsoft, install, and sign in to your Azure account. You can view your storage accounts, upload files, and manage containers. Right-clicking on files reveals options like copying, deleting, or changing access tiers. Creating new containers and copying blobs is straightforward, and Storage Explorer even generates AZ-Copy commands for you behind the scenes. Using AZ-Copy. AZ-Copy is a command line utility for advanced users or automation. To use it, authenticate with your Azure account, then run commands like AZ-Copy copy with source and destination URLs. If you use Azure Active Directory, ensure you have the storage blob data contributor role. AZ-Copy supports scripting and automation, making it ideal for repetitive tasks. Choosing the right tool. Azure Storage Explorer supports blobs, queues, tables, file shares, and Data Lake Storage Gen 2, making it versatile for general management. AZ-Copy is best for automating blob, file share, or Data Lake Storage Gen 2 transfers. Choose Storage Explorer for ease and versatility, or AZ-Copy for automation and scripting power. Protecting against data security threats in Azure. Soft Delete in Azure is a safety net that protects your data from accidental deletion. When you delete data, it is not gone immediately. Instead, Azure keeps it for a set period, giving you a chance to restore it if needed. How Soft Delete works. When data is deleted, Azure maintains it for a specified retention period. During this time, you can restore the data to its exact state at the moment it was deleted. Once the retention period ends, any data still marked as deleted is permanently erased. Retention periods and policies. Organizations can set the retention period anywhere from 1 day to 365 days, with the default being 7 days. If you update the retention policy, it only affects newly deleted containers. Previously deleted containers keep their original retention settings. Containers versus blobs. Container soft delete restores entire containers, not individual blobs. To recover a single blob, use blob soft delete or versioning. Both features work similarly, but container soft delete is for whole containers, while blob soft delete is for individual blobs or versions. Enabling soft delete in Azure portal. To enable soft delete, go to your storage account's data protection settings, check the boxes for blobs or containers, set your retention period, and save. Restoring deleted data. To restore, simply toggle to show deleted items, right-click, and select Undelete. Your data is back, just like that. Blob versioning overview. Blob versioning in Azure Storage lets you keep previous versions of your blobs so you can access or restore earlier states if something is changed or deleted. Think of it like the version history in Microsoft 365's SharePoint or OneDrive, where every change is tracked and recoverable. How blob versioning works. Whenever a blob is modified, Azure automatically creates a new version, preserving the previous state as an immutable snapshot. There is always one current version, but you can have multiple previous versions. These older versions cannot be changed except by promoting one to become the new current version, which creates a unique ID. Enabling blob versioning in Azure. To enable blob versioning, go to your storage account in the Azure portal, open the Data Protection menu, and check the box for versioning. You can choose to keep all versions or automatically delete them after a set number of days, which helps manage storage costs. Managing and restoring versions. To view or restore versions, open your container, select a blob, and check its versions menu. Right-click any version and select Make Current Version to restore it. This action creates a new version, preserving your data's history and integrity. Introduction to immutable storage. Immutable storage in Azure Blob keeps your critical data in a write-once, read-many state, or worm. This means your data can be read but cannot be modified or deleted for a set period. Types of immutability policies. Azure Blob Storage offers two main immutability policies: time-based retention and legal hold. Time-based retention keeps data in worm state for a specific duration, from 1 day up to 400 years. Legal hold policies, on the other hand, do not have a set time frame and remain until explicitly cleared. Configuring legal hold policies. To set a legal hold, right-click your container, select Access Policy, and add a legal hold policy. Assign a tag like Legal Hold Tag 1 and save. The policy stays until all tags are removed. Legal holds are not just for legal cases, they help protect any critical data. Setting time-based retention policies. For time-based retention, follow the same steps but choose your desired retention period, such as 365 days. The policy's retention period starts from the blob's creation date and can be viewed in the container's policy details. Locking and version level immutability. To ensure compliance, lock your time-based policy. Once locked, it cannot be deleted or edited, though the retention period can be extended up to 5 times. Version level immutability can also be enabled under data protection options for more granular control. Configuring Azure Blob Storage Lifecycle Management. Azure Blob Storage Lifecycle Management helps you save money by automatically moving your data to the most cost-effective access tier as its usage changes. Let's break down how to configure these policies for smarter storage. Access tiers explained. Azure Blob Storage offers 3 access tiers: Hot, Cool, and Archive. The Hot tier is for frequently accessed data and has the highest storage cost but lowest access cost. The cool tier is cheaper for storage but more expensive to access, and data must stay there for at least 30 days. The archive tier is the least expensive for storage, but data retrieval can take up to 15 hours and requires a minimum stay of 180 days. Setting up lifecycle rules. To automate data movement, create lifecycle rules in the Azure portal. For example, you can move blobs from hot to cool after 30 days, then to archive after 12 months, and finally delete them after 10 years. These rules help manage costs and compliance automatically. Using filters and access tracking. You can target specific blobs using filters like blob name prefixes, or enable access tracking to move blobs based on last access date instead of creation date, offering even more flexibility. Command line automation. For multiple accounts, download your policy as a JSON file and apply it using the Azure command line for efficient, large-scale management. Getting started with Azure Virtual Machines. An Azure Virtual Machine is an on-demand, scalable computer resource available in Microsoft Azure. Virtual machines, or VMs, give you the flexibility of virtualization without the need to purchase or maintain any physical hardware. However, you are responsible for tasks like configuration, patch management, and software installation. Common uses. Azure Virtual Machines are popular for hosting applications when you need more control over your computing environment. They are also commonly used to quickly deploy development and test environments. Thanks to their pay-as-you-go pricing, you only pay for VMs when you actually need them. Deployment and connectivity. Organizations often use Azure Virtual Machines to extend their on-premises data centers into Microsoft Azure. By attaching VMs to a virtual network, they can communicate with on-premises environments over a site-to-site virtual private network, or VPN, making hybrid cloud setups possible. Key design considerations. When designing with Azure VMs, consider naming conventions and deployment locations. Deploying VMs close to users improves performance. Also, think about VM sizing, the number of VMs needed, and be aware of Microsoft Azure's CPU and VM quotas. Finally, decide on the operating system and configuration your VMs will require. Careful planning ensures your Azure Virtual Machines meet your organization's needs efficiently and effectively. Introduction to Azure VM pricing. Azure Virtual Machines, or VMs, offer flexible pricing options to fit different needs and budgets. Whether you want to pay only for what you use or save with longer commitments, Azure has a solution for you. Pay-as-you-go option. With pay-as-you-go pricing, you pay for your compute capacity by the second with no upfront payments or long-term commitments. This option is perfect for customers who value flexibility and want to scale resources up or down as needed. You only pay for what you use, making it a cost-effective choice for dynamic workloads. Azure Virtual Machines, or VMs, come in a variety of types, each designed to meet specific workload needs. Understanding these options can help you choose the best virtual machine for your project or business requirements. General Purpose and Compute-Optimized Virtual Machines. General-purpose virtual machines offer a balanced ratio of CPU to memory, making them ideal for development and testing environments, small databases, and low-traffic web servers. Compute-optimized virtual machines, on the other hand, provide a higher CPU to memory ratio. These are perfect for medium-traffic web servers, network appliances, batch processing, and application servers. Memory-optimized and storage-optimized virtual machines. Memory-optimized virtual machines deliver a high memory-to-core ratio. They are commonly used for relational database servers, large caches, and in-memory analytics. Storage-optimized virtual machines focus on high disk throughput and input-output operations, making them suitable for big data, SQL, and NoSQL databases. GPU and high-performance compute virtual machines. GPU virtual machines are built for intensive graphic rendering and video editing, offering configurations with single or multiple graphics processing units. High-performance compute virtual machines are the fastest available, designed for demanding tasks like molecular modeling, genomic research, and financial risk modeling. Choosing the right virtual machine. Ultimately, the type of Azure virtual machine you deploy depends on your workload. By matching your needs to the right VM type, you can optimize performance, efficiency, and cost for your applications. Let us break down the essentials of availability sets and availability zones in Microsoft Azure and see how they help keep your applications running smoothly, even when things go wrong. Availability sets explained. An availability set in Azure is designed to provide redundancy and high availability for your virtual machines. By deploying at least 2 virtual machines into an availability set, you ensure that at least one remains available during planned or unplanned maintenance. This setup qualifies you for a Virtual Machine Service Level Agreement, or SLA, of 99.95% uptime. Each virtual machine in an availability set is assigned to update domains and fault domains, which help minimize downtime during maintenance or hardware failures. Availability zones explained. Availability zones take protection a step further. While availability sets guard against hardware failures within a single data center, availability zones protect your applications from complete data center failures. Each availability zone is a physically separate location within an Azure region, with its own power, networking, and cooling. Deploying virtual machines across multiple availability zones qualifies you for a 99.99% uptime SLA. Key differences and summary. In summary, availability sets protect against hardware failures inside a data center, while availability zones shield your applications from entire data center outages. Choosing the right option depends on your application's resiliency needs. Azure Virtual Machines, or VMs, are scalable computing resources you can create on demand in Microsoft Azure. They give you significant control over your computing environment, making them ideal for hosting applications that require custom configurations or specific software installations. Key benefits and use cases. One of the main advantages of Azure VMs is flexibility. You only pay for what you use, and you can quickly add or remove virtual machines to match your application's needs. Organizations often use Azure VMs for development and testing, or to move existing on-premises applications to the cloud. By connecting VMs to a virtual network, you can even extend your on-premises data center using a site-to-site virtual private network, or VPN. Before deploying a VM, consider where it should be located. Choose a region close to your users for the best performance. Also, select the right VM size based on your application's requirements. CPU-intensive applications need more processing power, while memory-intensive ones need more memory. Preparing for deployment. Finally, decide whether you need a Windows or Linux VM. With these basics in mind, you are ready to deploy and connect to your first Azure virtual machine using the Azure portal. Advanced VM management in Azure. Azure Virtual Machine Scale Sets are groups of identical, load-balanced virtual machines designed for high availability and easy management. They automatically adjust the number of instances based on demand or a set schedule, making them ideal for large-scale compute solutions. Key benefits and features. With scale sets, all virtual machines share the same configuration and base operating system image. This central management makes it simple to deploy, update, and maintain dozens or even hundreds of virtual machines. Applications hosted on scale sets benefit from redundancy and improved performance as requests are distributed across multiple instances using a load balancer. You can also use Azure Application Gateway for advanced traffic management and SSL termination. Auto-scaling and cost efficiency. The standout feature of a virtual machine scale set is auto-scaling. As application demand increases, the scale set automatically adds more virtual machines. When demand drops, it reduces the number of instances, helping control costs by only running what you need. Comparison with manual virtual machines. Unlike manual groups of virtual machines, scale sets automate instance creation, configuration, load balancing, and distribution across availability zones. This eliminates the need for manual scaling and monitoring. Monitoring and management. To monitor scale sets, use Azure Monitor for VMs and Application Insights. These tools automate performance tracking and application monitoring, ensuring your workloads run smoothly. When it comes to managing application performance and resources, understanding scaling strategies is essential. There are two main approaches: vertical scaling and horizontal scaling. Let's break down what each method means and when you might use them. Vertical scaling explained. Vertical scaling, also known as scaling up or down, involves changing the size of an existing virtual machine. For example, in Microsoft Azure, you might upgrade a virtual machine to one with more RAM and CPU, or downgrade to a smaller one with fewer resources. This process requires resizing the virtual machine, which results in a restart. Vertical scaling is useful when you want to adjust the power of a single server, such as scaling down over the weekend to save on compute costs. Horizontal scaling, or scaling out and in, means adding or removing virtual machine instances without changing their size. Instead of making one server bigger, you increase the number of servers handling the workload. This approach is ideal for public-facing websites or web applications, allowing you to meet demand by adding instances and reducing them when demand drops. Vertical scaling is best for adjusting individual server power, while horizontal scaling is suited for applications needing flexibility to handle fluctuating workloads. Microsoft recommends using horizontal scaling whenever possible for optimal performance and reliability. Managing virtual machines efficiently requires the right configuration management tools. Let us explore some of the most popular options for automating and maintaining your virtual machine environments. Ansible is an agentless automation engine that uses playbooks to define and execute configuration tasks on virtual machines. Chef, on the other hand, requires a Chef client installed on each VM, which communicates with centralized Chef servers to manage configurations. Puppet is another enterprise-ready automation platform. It uses agents on target VMs and a Puppet master to define and enforce desired configurations. Puppet can even integrate with tools like Jenkins and GitHub to streamline DevOps workflows. For Linux VMs, Cloud Init customizes machines during their initial boot, installing packages and configuring users without requiring agents. The Azure Custom Script extension works on both Linux and Windows VMs, downloading and executing scripts from sources like Azure Storage or GitHub. It is commonly used to automate tasks, such as installing software. Azure VM extensions perform post-deployment configuration, such as installing monitoring or security agents. PowerShell Desired State Configuration, or DSC, is a management platform that ensures VMs remain configured as required, using a local configuration manager engine on each VM. Choosing the right configuration management tool streamlines VM deployment, ensures consistency, and supports automation across your infrastructure. Azure Monitor for Virtual Machines, or VMs, is a powerful cloud-based tool designed to monitor both Azure virtual machines and virtual machine scale sets. It works with Windows and Linux systems, providing insights into performance and health. With Azure Monitor for VMs, you can track processes running on your machines, monitor dependencies on other resources, and even keep an eye on external processes. It is not limited to Azure alone. You can also monitor on-premises machines or those hosted by other cloud providers. One standout feature is the predefined trending performance charts, which display key operating system metrics. Another highlight is the dependency map, which visually shows how your virtual machines connect with other components across all your resource groups and subscriptions. The dependency map relies on the Microsoft Dependency Agent, which uses the Log Analytics agent to connect to Log Analytics. To use this feature, you need both agents installed and configured. Microsoft recommends using the Azure VM Dependency Agent extension for both Windows and Linux systems. You can set up Azure Monitor for VMs directly from the Insights page for a single VM or scale set. For monitoring multiple VMs, Azure Policy or PowerShell are recommended. Remember, you need the Log Analytics contributor role to enable these features. Automating deployments with Azure Resource Manager, ARM, templates. Deploying a single virtual machine in Azure is simple with the Azure portal, but if you need to deploy many resources or keep configurations consistent, Azure Resource Manager templates are essential. An Azure Resource Manager, or ARM, template is a file that defines all the details Azure needs to deploy resources like virtual machines or storage accounts. You can export an ARM template for any resource you've deployed by selecting Export Template in the Azure portal. ARM templates start with the schema URL, which defines the template language version. There's a content version, parameters, variables, and the resources section. The resources section is the heart of the template, specifying each resource's type, name, location, and configuration settings. Parameters let you customize deployments without editing the template. For example, you can set a storage account's name as a parameter. If you have many parameters, use a parameters file to set values and pass it during deployment. You can export templates for single or multiple resources from the Azure portal. Exported templates are great for reviewing or updating resources, but may not always be perfect for new deployments. Creating an Azure Resource Manager or ARM template for a storage account might seem overwhelming at first, but with Visual Studio Code and the ARM Resource Manager Tools extension, the process becomes much more manageable and efficient. Once you have Visual Studio Code and the ARM extension installed, start by creating a new file named storage.json. On the first line, type ARM to access basic ARM template options. Select the first template to get a blank starting point. In the Resources section, place your cursor between the square brackets and start typing storage. Choose ARM storage from the suggestions. This automatically fills in the essentials for a storage account. Now, personalize your template. Change the storage account name to something unique, like CAS Storage 3. Notice that updating the name also changes the display name. Leave the kind as Storage V2, which is standard. For the SKU, delete Premium LRS, press Ctrl and space, and select Standard LRS for a more affordable option. Remove the tier value, press Ctrl and space, and pick Standard. Save your file. To deploy, open a terminal in Visual Studio Code. Log into Azure with AZ Login. Use the command AZ Deployment Group Create with your resource group and template file. Check the Azure portal to confirm your new storage account is live. Deploying a virtual machine using an Azure Resource Manager template or ARM template involves more steps than deploying something simple like a storage account. Let's walk through the essentials. Start by creating a new template file, vm.json, in Visual Studio Code. With the ARM extension, just type ARM and select the first option. In the Resources section, type VM and choose a Windows virtual machine. The extension automatically adds all the necessary resources. You'll see resources like a storage account for the operating system disk, a public IP address, a network security group, a virtual network, a subnet, a network interface, and finally, the virtual machine itself. Each resource is interconnected, and the ARM extension helps visualize these dependencies using the ARM Viewer diagram.
Before deploying, update the OS profile section with a secure administrator password. Never store passwords directly in the template for security reasons. Instead, reference a password stored in Azure Key Vault using the reference keyword. For Linux VMs, consider using SSH keys. Once your template is ready and secure, open a new terminal and deploy using the appropriate command. Check the Azure portal to confirm your virtual machine and all supporting resources have been created successfully.
When working with Azure Resource Manager templates or ARM templates, it is smart to use parameters for values that might change with each deployment, like the name of a virtual machine. This makes your templates flexible and easier to reuse. To turn a value into a parameter in Visual Studio Code, simply click on the value, select the light bulb, and choose Extract Parameter. For example, you might call the parameter vmName and describe it as name of the virtual machine. The template will automatically update, replacing the value and adding your parameter to the Parameters section, complete with a default value. When deploying, you can set this parameter on the command line using --parameters vmName equals, or specify a parameter file.
Sometimes a value like the network interface name is used in multiple places and is built from other values. Instead of repeating complex expressions, you can highlight the code, click the light bulb, and select Extract Variable. Name it something clear like network interface. Now, you can use this variable throughout your template, making your code cleaner and easier to maintain. Parameters let you customize deployments, while variables simplify your template's logic. Together, they make ARM templates more powerful, readable, and maintainable for any Azure deployment scenario.
Azure Resource Manager templates, or ARM templates, are more than just configuration files. They offer powerful features that let you automate and customize your Azure deployments, making your infrastructure setup both efficient and repeatable. ARM templates include a wide range of functions, similar to those found in programming languages. For example, you can use string functions like concat to combine text, or numeric and logical functions for calculations and conditions. There are even comparison functions and the ability to create your own custom functions. These tools help you build flexible and dynamic templates for your Azure resources, making your deployments powerful and adaptable. One especially useful function is Copy Index. Imagine you need to create 3 data disks for a virtual machine. Instead of repeating the configuration for each disk, you can use a copy block. By setting the count to 3 and using Copy Index, the template loops through and assigns a unique logical unit number, or LUN, to each disk automatically, reducing repetition and errors. You can make this even more flexible by using a parameter like number of data disks to set the count. This way, you can easily adjust the number of resources created without rewriting your template. With these features, ARM templates make Azure deployments powerful and adaptable.
Introduction to Azure App Service.
When it comes to hosting a website on Microsoft Azure, you have several options to choose from, each tailored to different needs and levels of complexity. Let's break down the main choices and see why one stands out for most developers. For simple, static websites that do not require user interaction, Azure Storage is a straightforward solution. If you need something more advanced, like running a content management system such as WordPress, you can use an Azure virtual machine. For microservices-based applications in Docker containers, Azure Kubernetes Service is a strong choice. However, the most popular option is Azure App Service. This platform as a service manages the underlying infrastructure for you, so you do not have to worry about operating system updates or patches. App Service supports a wide range of programming languages and frameworks, including ASP.NET, Java, Ruby, Node.js, PHP, and Python. You can even deploy custom Docker containers if your app uses a different language. App Service integrates seamlessly with Visual Studio, Visual Studio Code, and continuous integration tools like Azure DevOps and GitHub. It offers high availability with a 99.95% uptime guarantee, automatic scaling, and built-in security features for enterprise-grade reliability. Deploying an application on Azure App Service is surprisingly simple. With just a single command, you can have your app up and running in the cloud in minutes. You have several ways to deploy, like Visual Studio or Visual Studio Code, but today, let's use the Azure Command Line Interface, or AZ-CLI. Microsoft's Cloud Shell in the Azure portal gives you instant access to the AZ-CLI without installing anything. The first time you use it, you'll be prompted to create a storage account for Cloud Shell's virtual machine. Before deploying, you need an app. Here, we'll use a sample.NET application. With a simple command, you can download the app and move into its folder, ready for deployment. To deploy, use the command azwebapp-up-sku f1-name your app name. This tells Azure to create a web app using your code on the free tier. If you skip options like resource group or location, Azure uses defaults and Windows as the operating system. Want to update your app? Edit the homepage file in Cloud Shell's editor, save your changes, and run the deployment command again. Refresh your web page to see the update instantly. That's how easy it is to create and update a simple app on Azure App Service. Azure App Service plans let you choose the infrastructure for your web apps, while Azure manages the underlying hardware. But you still need to decide on a few key settings to get started. First, pick your operating system, Windows or Linux. Next, select the region closest to your users, like East US. Remember, you cannot change a plan's region later. Finally, choose a pricing tier, which determines your compute resources and available features. For development and testing, the free tier offers 60 CPU minutes per day. Need more? The shared or D1 tier gives you 240 CPU minutes and allows custom domains. Both free and shared tiers have 1 GB of RAM and storage. The basic tier provides dedicated virtual machines and 10 GB of storage. Standard tier increases storage to 50 GB and supports auto-scaling up to 10 virtual machine instances. Premium offers more resources and up to 30 instances. The isolated tier gives you a private environment with up to 100 instances in its own virtual network. You can host multiple apps in one plan, but they share resources. Scale out by adding more virtual machines, or scale up by switching to a higher tier. Choose your settings carefully, especially region and pricing tier, to ensure your apps run smoothly and efficiently. Auto-scaling on Azure App Service. If your app on Azure App Service needs more resources, You can scale up to a higher pricing tier. However, this is not dynamic and does not adapt to changing demand. Scaling options. A smarter approach is scaling out and scaling in, where Azure adds or removes virtual machines as needed. This feature is available on basic plans and higher, but true autoscaling, which happens automatically, requires a standard plan or above. Autoscaling with Azure Monitor. Autoscaling is managed by Azure Monitor. You can access autoscale settings through your service plan's Scale Out menu or directly in Azure Monitor by selecting Autoscale and choosing your service plan. You define scale conditions with rules based on metrics like CPU percentage, memory usage, or network activity. For example, you might add an instance if average CPU usage exceeds 75% for 10 minutes. Scale out rules always take priority over scale in rules. You can also schedule scaling to a specific number of instances at set times, such as increasing capacity on weekdays. Scheduling can be combined with metric-based rules for flexible, conflict-free autoscaling tailored to your app's needs. Getting started with Azure Virtual Networks. Azure Virtual Networks, or VNets, are the backbone of many Azure deployments. They let resources like virtual machines communicate securely with each other, on-premises networks, and the internet. Think of a VNet as a digital version of a physical network, but with added benefits like scalability, availability, and isolation. Before deploying a VNet, understand these terms: address space and subnets. The address space is a range of Internet Protocol addresses you define following RFC 1918 standards. For example, if you set 192.168.0.0/16 as your address space, connected resources get addresses from that range. Subnets let you divide this space into smaller segments, helping organize and secure resources efficiently. Each VNet is tied to a single Azure region and a specific subscription. If you need connectivity across regions, use virtual network peering to link VNets in different locations. Avoid overlapping address spaces with your on-premises networks to prevent routing issues. Do not create a subnet that uses the entire address space. Always leave room for future growth. Fewer, larger VNets reduce management overhead. Secure your VNets using network security groups. These filter traffic to and from resources, letting you control what enters or leaves each subnet. Azure Virtual Networks are essential for secure communication between resources, the internet, and on-premises networks. Let's explore how these connections work and the options available for different scenarios. Communication within Azure. Within Azure, resources like virtual machines, scale sets, and app service environments can be deployed to a virtual network, enabling secure communication among them. Virtual network service endpoints extend a network's private address space to services like Azure storage accounts and Azure SQL databases, allowing you to secure these resources to only your virtual network. Another option is VNet peering, which connects two virtual networks so resources in each can communicate directly. By default, all resources in an Azure Virtual Network can communicate outbound to the Internet. To allow inbound communication from the Internet, you can assign a public IP address to a resource or use a public load balancer. To connect Azure to on-premises networks, you have several options. A point-to-site VPN connects individual computers, while a site-to-site VPN links entire networks securely over the Internet. For a private, robust connection, Azure Express Route connects your on-premises network directly to Azure without using the Internet. Azure Virtual Networks enable secure communication between resources, the Internet, and on-premises environments using flexible options tailored to your needs. Let's explore how Azure helps you manage network traffic with filtering, routing, and integration. These tools are essential for keeping your cloud environment secure, efficient, and connected. In Azure, you can filter traffic between subnets using security groups or network virtual appliances. Network security groups let you apply rules to specific network interfaces or entire subnets. For more flexibility, application security groups allow you to group network interfaces and apply targeted rules. Network virtual appliances, or NVAs, are specialized virtual machines that can act as firewalls or optimize wide area networks. Azure automatically routes traffic between subnets, virtual networks, and the Internet. If you need custom routing, use route tables to define specific paths for your traffic. For advanced scenarios, Border Gateway Protocol routes, or BGP routes, are used when connecting Azure virtual networks to on-premises networks through ExpressRoute or Azure VPN Gateway. Integrating Azure services with virtual networks enables private access from your virtual machines. You can do this by deploying dedicated instances, using private links for secure connections, or configuring service endpoints for optimized direct access to Azure resources. With these Azure features, you can filter, route, and integrate network traffic to build secure and connected cloud solutions. Welcome to VPN Gateways. In this video, we will explore the essential role of VPN gateways in Azure and how they enable secure, encrypted connections between networks. Whether you are connecting on-premises infrastructure or linking Azure virtual networks, VPN gateways are a critical component. Before setting up a VPN connection in Azure, you must first deploy a VPN gateway. This special type of virtual network gateway is designed to send encrypted network traffic between an Azure virtual network and an on-premises network over the public internet. You can also use it to connect different Azure virtual networks securely over the Microsoft network. Each virtual network can have only one VPN gateway, but that gateway supports multiple connections. When you deploy a VPN gateway, Azure automatically creates at least 2 hidden virtual machines in a gateway subnet. These machines handle routing and gateway services, but you cannot configure them directly. You can specify the gateway type as either VPN or ExpressRoute, depending on your needs. Deployment can take up to 45 minutes. Once complete, you can establish IPsec or IKE VPN tunnels for VNet to VNet, site to site, or point to site connections. Stay tuned for upcoming demos on deploying and using VPN gateways in Azure. Today, we are diving into the essentials of site-to-site virtual private networks, or VPNs. If you need to securely connect your on-premises network to an Azure virtual network, this is the solution you'll want to know about. A site-to-site VPN creates a secure tunnel between your on-premises network and your Azure virtual network. This tunnel uses protocols like Internet Protocol Security, or IPsec, and Internet Key Exchange, or IKE, to keep your data safe as it travels between locations. Site-to-site VPNs are ideal for organizations that need a reliable, encrypted connection between their local infrastructure and cloud resources. They allow seamless communication and data transfer, making hybrid cloud setups both practical and secure. First, create your Azure virtual network. Next, add a gateway subnet, then deploy a VPN gateway. This step can take up to 45 minutes. Afterward, set up a local network gateway to represent your on-premises endpoint. Configure your on-premises VPN device, ensuring it has a public IP address for Azure to connect. Finally, establish the VPN connection in Azure and verify everything is working. That's your foundation for a secure site-to-site VPN. Point-to-site VPNs are a secure way for individual client computers to connect to a virtual network in Microsoft Azure. This setup is especially useful for remote workers who need access to resources on an Azure virtual network from anywhere. With a point-to-site VPN, the connection is initiated directly from the client computer. This means each user connects individually rather than through the shared gateway. It's a flexible solution for organizations with remote employees or those who need secure, on-demand access to cloud resources. When setting up a point-to-site VPN, you can choose from several protocols. OpenVPN protocol is SSL TLS based and works across most devices, including Android, Windows, Linux, and Mac OS X. Secure Socket Tunneling Protocol, or SSTP, is proprietary to Windows and also uses TLS. IKEv2 VPN is a standards-based IPsec solution suitable for Mac OS X devices. Users must be authenticated before connecting. Options include Azure Certificate Authentication, which requires a client certificate, Azure Active Directory Authentication for OpenVPN connections, and traditional Active Directory domain authentication using a Radius server integrated with the domain controller. Point-to-site VPNs offer secure, flexible remote access to Azure networks, supporting multiple protocols and authentication methods to fit different organizational needs. ExpressRoute is a service that lets you extend your on-premises networks into Microsoft Azure using a private connection. This connection is set up through a third-party connectivity provider, offering a direct link between your network and Azure. You can use ExpressRoute to connect from an any-to-any network, a point-to-point Ethernet network, or through a virtual cross-connection at a co-location facility. Importantly, ExpressRoute connections do not traverse the public internet, making them inherently more secure and reliable. ExpressRoute provides dynamic routing between your on-premises networks and Microsoft using Border Gateway Protocol, or BGP. Built-in redundancy increases reliability, and Microsoft offers a 99.95% uptime service level agreement for dedicated circuits. ExpressRoute circuits are available in bandwidths ranging from 50 megabits per second up to 10 gigabits per second. You can even increase your bandwidth without disconnecting existing connections, making it easy to scale as your needs grow. Choose between unlimited data or metered data billing models. The ExpressRoute Premium add-on increases route limits, allows more virtual network links, and enables global connectivity across Microsoft regions, except for national clouds. If you need to connect two different Azure virtual networks, Virtual Network Peering, or VNet Peering, is the solution. VNet Peering lets you seamlessly link separate Azure virtual networks, making them appear as one for connectivity purposes. Azure supports two types of peering. Virtual Network Peering connects networks within the same Azure region, while Global Virtual Network Peering links networks across different Azure regions. Both options use Microsoft's backbone infrastructure, ensuring reliable and efficient connectivity. With VNet Peering, you get low-latency, high-bandwidth connections between Azure resources, even if they are in different subscriptions, Azure Active Directory tenants, or regions. You can connect networks created with the Azure Resource Manager or even link Resource Manager networks to those built with the classic deployment model. Importantly, setting up peering causes no downtime for your resources. Traffic between peered networks stays on the private Microsoft backbone, so there's no need for public internet, gateways, or encryption. Network latency between virtual machines in peered networks is just as low as within a single network. You can also apply network security groups for added control. Load balancing with Azure. Azure load balancers are essential tools in cloud networking, designed to distribute incoming network traffic across multiple backend resources. These resources are usually virtual machines grouped in a backend pool or instances within a virtual machine scale set. There are two main types of Azure load balancers, public and internal. Public load balancers handle internet traffic, requiring a public IP address on the front end. They also enable outbound internet connections for virtual machines inside your Azure virtual network by translating private IP addresses to public ones. Internal load balancers, also called private load balancers, only use private IP addresses and are ideal for balancing traffic within your Azure virtual network or from connected on-premises networks.
When deploying a load balancer, you can choose between basic and standard SKUs. The standard load balancer supports up to 1,000 instances and offers availability zone support, while the basic version supports up to 300 instances and lacks zone redundancy. Load balancers are commonly used to increase application availability and provide outbound connectivity for virtual machines. Microsoft recommends standard load balancers for their enhanced security built on a zero-trust model and superior features.
Let's break down the essential components that make up an Azure load balancer. Each part plays a unique role in distributing and managing network traffic efficiently. The front-end IP configuration is the entry point for clients. It can be either a public or private IP address, and a load balancer can have multiple front-end IPs assigned. This is where users connect. The back-end pool is a collection of virtual machines or instances that handle incoming requests. When you add or remove instances, the load balancer automatically updates itself to ensure traffic only goes to available resources. Health probes monitor the status of backend pool instances. If a probe detects an unhealthy instance, the load balancer stops sending traffic to it, ensuring reliability. Load balancing rules define how incoming traffic is distributed across backend instances. For example, a rule might route all HTTP traffic on port 80 to the backend pool. High availability ports allow you to load balance all TCP and UDP flows across all ports, making it easier to manage large numbers of connections. Azure Application Gateway is a powerful load balancer designed specifically for web applications. Unlike traditional load balancers that operate at the transport layer, Application Gateway works at the application layer, or layer 7 of the OSI model, providing advanced routing capabilities for your web traffic. When a request reaches the Application Gateway, it can make routing decisions based on HTTP attributes like the URI path or host headers. For example, if your website hosts both images and videos, the gateway can direct requests for URLs containing /images to one backend pool and requests for /video to another. These backend pools can include virtual machines, virtual machine scale sets, or even on-premises servers, giving you flexibility in managing your resources. Key features. Azure Application Gateway offers several essential features. SSL termination lets the gateway handle encryption and decryption, reducing the load on backend servers. Autoscaling, available in the standard version 2, automatically adjusts resources based on traffic. The Web Application Firewall, or WAF, protects against common exploits like SQL injection and cross-site scripting. Zone redundancy allows the gateway to span multiple availability zones for increased reliability. Azure Application Gateway provides intelligent, secure, and scalable traffic management for web applications. Explore its full range of features to optimize your web infrastructure and enhance your application's performance and security. Let's break down the key components that make up an application gateway, a powerful tool for managing and routing web traffic efficiently and securely. Every application gateway starts with a front-end IP address. This can be public, private, or both, but only one of each type is supported. Listeners are then configured to watch for incoming connection requests. You can specify the protocol, port, host name, and IP address for each listener. If a request matches the listener's configuration, it is accepted and processed. Request routing rules are the glue connecting listeners, backend pools, and HTTP settings. These rules determine how accepted requests are forwarded to backend servers. HTTP settings define the ports and protocols used, whether traffic is encrypted, and if cookie-based session affinity is enabled to keep user sessions consistent. Backend pools are groups of resources like network interface cards, virtual machine scale sets, public or internal IP addresses, fully qualified domain names, or multi-tenant backends such as app service. The gateway directs traffic to these resources based on the routing rules. Health probes continuously monitor back-end resources. If a resource becomes unhealthy, it is removed from service until it recovers. This ensures only healthy resources handle traffic, maintaining reliability and performance. Azure Front Door is a powerful service from Microsoft designed to optimize and secure your web applications at a global scale. Delivered from the edge of Microsoft's global network, it brings your content closer to users worldwide. With Azure Front Door, you get global load balancing for both applications and microservices. This means your apps can seamlessly fail over across different regions or even different clouds, ensuring high availability. You can define, manage, and monitor global routing for your web traffic, making it easier to deliver reliable experiences to users everywhere. One of the standout features is improved application performance, achieved through a split transmission control protocol-based Anycast protocol. This ensures users connect to the nearest point of presence, reducing latency and speeding up access. Smart health probes constantly monitor back-end resources for latency and availability. If a back-end goes down, these probes enable quick failover to healthy resources, keeping your app running smoothly. Azure Front Door offers URL-based routing, letting you direct traffic based on URL paths. Cookie-based session affinity ensures users stay connected to the same backend throughout their session. Other features include transport layer security termination, custom domain support, and URL redirection. Let's explore how the Azure Web Application Firewall, or WAF, helps protect your web applications from common threats. This lesson will introduce you to its core features and how it simplifies security for your apps. A web application firewall is designed to shield web applications from vulnerabilities and exploits, such as SQL injection and cross-site scripting attacks. While developers can code protections into each app, this approach is tedious and requires constant updates. WAF centralizes and streamlines this protection. Azure's Web Application Firewall can be deployed with several services, including Application Gateway, Azure Front Door, and the Azure Content Delivery Network. With Application Gateway, WAF protects multiple websites, up to 40 on a single instance, without changing application code. Custom WAF policies can be created for different sites, offering flexibility and robust security. When used with Azure Front Door, WAF inspects every incoming request at the edge of the Azure network, blocking threats before they reach your virtual network. With Azure Content Delivery Network, WAF mitigates attacks closer to their source, protecting your web content globally. In summary, Azure's Web Application Firewall offers centralized, customizable protection for your web applications across multiple Azure services. Azure Traffic Manager is a unique load balancer that uses the Domain Name System, or DNS, to distribute traffic across global Azure regions. Unlike traditional load balancers, it directs users to the closest service endpoint, improving both availability and responsiveness for your applications. When a user tries to access your app, Traffic Manager uses DNS to determine which endpoint is best, based on the routing method you choose and the health of your endpoints. It does not act as a proxy or gateway. Instead, it simply points users to the right place, and connections go directly to your service. Traffic Manager offers several routing methods. Priority sends all traffic to a primary endpoint, with backups ready if needed. Weighted splits traffic based on your defined weights. Performance directs users to the lowest latency endpoint. Geographic routes users based on their location, which is helpful for compliance. Multi-value supports only IP addresses, and Subnet maps specific IP ranges to endpoints. Traffic Manager is a DNS-based solution, making it flexible and resilient. It works with any internet-facing service, inside or outside Azure, and helps keep your applications available and fast for users worldwide. When you enter a web address like Microsoft.com into your browser, your computer needs to find the server hosting that website. This is where the Domain Name System, or DNS, comes in. DNS translates the easy-to-remember domain name into a numerical IP address, allowing your device to connect to the correct server on the internet. If you are setting up a website with a new domain name, you need to make sure your domain is reachable online. The first step is to choose name servers to host your DNS information. Most people use existing name servers provided by their hosting company, such as Azure DNS, but large organizations might have their own. Next, you create a public zone on the name servers. A zone is a container for DNS records related to your domain. The most important record is the A record, which links your domain name to your web server's IP address. You can also create child zones for subdomains, like support.microsoft.com. Finally, register your domain name with a trusted registrar. During registration, you provide the IP addresses of your name servers. This ensures that when someone types your domain, DNS knows where to find your website. Azure DNS is a powerful service for hosting and managing your domain name system records. Today, let's walk through how to connect a public domain, like contoso.com, to your Azure web app. First, you need to reserve your domain name, such as contoso.com, through a domain registrar. Once you own the domain, head to Azure DNS and create a DNS zone named after your domain. Azure DNS will automatically generate essential records, including name server or NS records for your zone. Next, create an A record in your DNS zone. This record links contoso.com to the IP address of your Azure App Service web app. Then, in Azure App Service, add contoso.com as a custom domain so your app can accept requests for that address. Return to your registrar and delegate your domain to Azure DNS by entering the Azure name servers. To prove ownership, add a TXT record with a unique string provided by Azure App Service. Once validated, your domain is officially connected. To use your domain for Azure user IDs, add it as a custom domain in Azure Active Directory. Verify ownership with a TXT record, and set it as your organization's default domain. When working with virtual machines in Azure, using names instead of IP addresses makes management much easier. But since computers communicate using IP addresses, you need a way to translate those names into addresses. This is called name resolution. The simplest option is Azure-provided name resolution. When you create a virtual network, or VNet, Azure automatically lets your virtual machines communicate using host names. Each machine's name is placed in the internal .cloudapp.net domain, but you can just use the hostname like VM1 within the same VNet. If you need name resolution across multiple Azure virtual networks, Azure DNS Private Zones is the preferred choice. This service is part of Azure DNS and is designed specifically for private virtual networks, handling name resolution for systems that are not accessible from the Internet. For organizations with on-premises DNS servers, you can run your own DNS server on a virtual machine in Azure. This setup allows both Azure and on-premises resources to communicate using names by forwarding requests between environments. Finally, Azure DNS Private Resolver is a fully managed service that forwards DNS requests to your on-premises DNS servers, eliminating the need to manage DNS servers in Azure yourself. When you create a virtual network in Azure, name resolution is set up automatically. This lets virtual machines, or VMs, communicate using host names instead of IP addresses. However, this default setup has limitations, especially across peered virtual networks. To overcome these limits, use Azure DNS Private Zones. For example, create a private zone called private.contoso.com, then link it to your virtual network. Enable auto-registration so Azure DNS automatically manages address records for your VMs, saving you manual work. If you have two peered virtual networks, link both to the same private DNS zone and enable auto-registration. Azure DNS will register all existing and new VMs, allowing seamless hostname resolution across both networks. Just ensure host names and IP addresses do not overlap. For many networks, a hub-and-spoke topology simplifies management. Designate one network as the hub, connect others as spokes, and use a virtual network gateway for routing. Link all networks to the same private DNS zone with auto-registration for unified name resolution. Need both public and private access to the same domain? Azure DNS supports split horizon. Create public and private zones with the same name, like contoso.com, so internal and external requests resolve to the correct IP addresses automatically. Configuring networking in Azure App Service. When you create an app with Azure App Service, it comes with a default URL ending in .azurewebsites.net. For a professional website, you'll want to set up a custom domain. First, make sure your app service plan is on a paid tier. Custom domains are not supported on the free F1 tier. Also, ensure you've registered your domain name and can edit its DNS records through your domain provider. Go to your app's custom domain settings in Azure. Copy the custom domain verification ID, your app's IP address, and the existing .azurewebsites.net URL. Save these details in a text editor for easy access. At your domain provider's site, create an A record for the root domain using your app's IP address. For a subdomain like www, create a CNAME record pointing to your app's Azure URL. Add TXT records named ASUID for the root and ASUID.www for the subdomain, both using the verification ID. Return to Azure's Custom Domains page. Add your domain, select the correct DNS record type, and click Validate. If everything is set up correctly, your app will now use your custom domain. If you have set up a custom domain for your app, it is crucial to secure it with HTTPS. This means enabling Transport Layer Security, or TLS, and Secure Sockets Layer, or SSL, to protect your users' data. First, make sure your app service plan is at least on the basic tier. Free and shared tiers do not support TLS or SSL for custom domains. Next, you will need a TLS or SSL certificate file, which contains both a private key and a public certificate. The easiest way to get a certificate is to use the free App Service Managed certificate provided by DigiCert, a trusted certificate authority. Just go to your app's TLS or SSL settings, select Private Key Certificates, and create a managed certificate for your custom domain. Once you have your certificate, bind it to your domain. Choose SNISSL for flexibility, as it works with all major browsers since 2007. To force secure connections, enable the HTTPS only option and keep the minimum TLS version at 1.2. For extra protection, enable TLS mutual authentication, also called client certificate authentication. Set client certificate mode to Require in your app's configuration and add code to handle authentication using the XARR client CERT header. Azure App Service apps are accessible by default over the internet, but sometimes you need more control over how your app connects to other resources or who can access it. To restrict who can access your app, you can set up access restriction rules. These rules allow or deny specific IP addresses or address ranges. If you want resources in an Azure Virtual Network, or VNet, to connect securely, you can use service endpoints. Service endpoints are enabled on a subnet, allowing only that subnet to access your app. A more advanced option is creating a private endpoint. This assigns a private IP address from your VNet to your app, making it accessible only within your network. Microsoft recommends private endpoints over service endpoints, especially if you need to connect from on-premises environments using Azure ExpressRoute or Azure VPN. Outbound connections. For outbound connections, App Service Hybrid Connections let your app securely connect to resources in a VNet or on-premises. You install Hybrid Connection Manager on a Windows server to relay traffic over port 443. VNet integration. Regional VNet integration is the simplest way for your app to access resources in the same region's VNet. Just select the VNet in your app's networking settings and you are ready to go. Implementing Azure Network Security. Azure Virtual Networks, or VNets, are the foundation of security in Microsoft Azure. Think of a VNet as a logically isolated section of Azure's cloud network, carved out and dedicated to your specific subscription. This isolation ensures your resources are protected and connected only as you intend. VNets allow you to securely connect various Azure resources together. But what if you need to link your cloud resources to your physical on-premises network? Azure offers two main options. First, site-to-site virtual private networks, or VPNs, connect your VNet to your on-premises network over the internet. For even greater security and reliability, Azure's ExpressRoute provides a dedicated wide-area network link that never touches the public internet. Each virtual network is scoped to a single Azure region, which is a group of data centers within a specific latency boundary. VNets are isolated from each other, and you can assign a private IP address space to each one, ensuring resources remain secure and separated. Within a VNet, you can create subnets, smaller ranges of IP addresses, to organize resources. You can even use a custom domain name system, or DNS, server for name resolution, giving you full control over your network environment. In Azure, every resource on a virtual network, such as virtual machines and load balancers, needs a unique IP address. This is similar to how devices on a physical network require their own addresses to communicate. Azure Virtual Networks use two main types of IP addresses, private and public. Private IP addresses are assigned from a defined range within the virtual network and are used for internal communication between resources. Public IP addresses, on the other hand, enable Azure resources to connect with external resources outside the virtual network. Private IP addresses can be allocated dynamically or statically to virtual machines. Dynamic allocation means the address is assigned automatically from the available range, while static allocation reserves a specific address for a resource. The choice depends on your network's requirements. Virtual networks in Azure can be divided into subnets. each subnet has its own range of IP addresses within the parent network's address space. Subnetting helps organize resources and manage network traffic more efficiently. Careful planning of IP address ranges and subnetting not only simplifies network management, but also enhances security by segmenting hosts and masking internal network details from external routers. Virtual private networks, or VPNs, are essential tools for extending your physical on-premises networks into Microsoft Azure. By creating a secure, encrypted tunnel, VPNs make it possible for your organization to connect remote resources and users to your cloud environment, ensuring seamless and protected communication. VPNs are not limited to just connecting on-premises networks to Azure. You can also use them to link separate virtual networks, even across different cloud providers. For instance, a site-to-site VPN can connect an Azure virtual network to another virtual network in Amazon Web Services, or AWS, and Google Cloud Platform, or GCP. This flexibility allows organizations to build hybrid and multi-cloud environments that work together efficiently. For organizations seeking a more robust and reliable connection between their on-premises network and Azure, ExpressRoute is an excellent alternative to traditional VPNs. ExpressRoute enables you to establish a private connection to Azure virtual networks, keeping your traffic off the public internet. This enhances both security and performance for critical workloads. If you need to grant access to a single user, a point-to-site VPN is the solution. This type of connection is similar to tools like FortiGate or Cisco AnyConnect, allowing individual users to securely connect to Azure resources from virtually anywhere. To start creating a route-based site-to-site VPN in Microsoft Azure, first set up a gateway subnet within your Azure virtual network. This subnet should be small, like a /27 range, and must not overlap with any existing subnets. Next, deploy a virtual network gateway in Azure. This gateway acts as the Azure endpoint for your VPN connection. Assign it to the same region and resource group as your virtual network, and select the route-based VPN option for flexibility and compatibility. Now, create a local network gateway to represent your on-premises VPN device. Enter the public IP address of your on-premises VPN device and specify the address range for your on-premises network. This allows Azure to route traffic correctly. With both gateways in place, configure the site-to-site VPN connection. Use the same pre-shared key on both the Azure and on-premises devices. Select IKE version 2 for enhanced security and reliability. Finally, download the configuration script for your specific on-premises VPN device, update any required parameters, and apply it. Once configured, check the connection status in Azure. When it shows connected, your VPN is successfully established. Azure Front Door is a Microsoft service designed to manage and optimize global web traffic routing. It helps organizations deliver high-performance applications and content to users worldwide, ensuring both speed and reliability for consumer and enterprise-grade apps. Operating at Layer 7, the HTTP and HTTPS layer, Azure Front Door leverages the Anycast protocol and Microsoft's global network to improve connectivity. It routes client requests to the fastest and most available backend, whether hosted inside or outside Azure. With instant global failover, even if an entire Azure region fails, your application remains available. Azure Front Door accelerates app performance by connecting users to the nearest front door point of presence. Smart health probes monitor backend latency and availability, automatically failing over if a backend goes down. The service supports multiple traffic routing methods, backend health monitoring, and URL-based routing, allowing efficient app deployment topologies. Session affinity keeps user sessions on the same backend, which is essential when session state is stored locally. Azure Front Door supports SSL termination at the edge, HTTPS for custom domains, and features like custom web application firewall rules, URL redirection and rewrite. It also supports IPv6 and HTTP2, making it a robust, secure solution for global web applications. Network security groups are essential for protecting resources in an Azure virtual network. They act as filters, controlling which network traffic can reach or leave your Azure resources, making them a fundamental part of your cloud security strategy. Each network security group contains security rules that you define. These rules can allow or deny inbound or outbound traffic. Every rule needs a unique name, a priority number between 100 and 4096, a source or destination, a protocol, a direction, a port or port range, and an action. The source or destination can be a specific IP address, any IP address, a CIDR block, a service tag, or an application security group. Supported protocols include Transmission Control Protocol, or TCP, User Datagram Protocol, or UDP, Internet Control Message Protocol, or ICMP, or simply any. Rules are processed in order of priority, with lower numbers coming first. Once traffic matches a rule, no further rules are evaluated. You can specify individual ports like port 443 or a range such as ports 10,000 to 11,000 to simplify management. Actions for each rule are either allow or deny. In the next lesson, you will learn how to create a network security group and configure your own security rules. Creating network security rules in Azure starts within a network security group, or NSG. By default, each NSG comes with a basic set of rules, but you can add custom inbound or outbound rules as needed. When adding a rule, you can define the source. Options include any, application security group, IP addresses, or service tag. For IP addresses, specify private IPs or CIDR ranges, not public IPs, especially for Azure virtual machines. Service tags are predefined identifiers for categories like HTTP, RDP, or storage. The destination field works similarly, letting you target any IP addresses, virtual network, or application security group. Remember, for Azure VMs, always use private IPs in both source and destination fields. Specify source and destination port ranges as single ports, ranges, or comma-separated lists. Microsoft recommends using any for source ports, since port filtering is usually applied to destination ports. Choose the protocol, any, TCP, UDP, or ICMP. Assign a unique priority between 100 and 4096. Lower numbers mean higher priority. Microsoft suggests leaving gaps between priorities for easier future changes. Rule names must be unique, up to 80 characters, and follow specific character rules. Descriptions are optional but helpful. With these settings, you are ready to create effective network security rules in Azure. Azure Firewall is a cloud-based network security service designed to protect Azure virtual network resources. It is fully stateful, meaning it tracks and manages the state of network connections, and it offers built-in high availability. With unrestricted cloud scalability, Azure Firewall adapts to your organization's needs as they grow. Organizations can centrally create application and network connectivity policies across multiple subscriptions and networks using Azure Firewall. It uses a static public IP address for resources behind it, making it easy for external firewalls to identify traffic from the protected virtual network. Azure Firewall supports Application Fully Qualified Domain Name, or FQDN, traffic filtering rules, as well as network traffic filtering rules. Additional features include support for FQDN tags, service tags, and threat intelligence. Built-in high availability and availability zone spanning ensure your network remains protected and resilient. You can even associate up to 100 different public IP addresses with a single Azure firewall, providing flexibility for complex environments. Azure Firewall is fully integrated with Azure Monitor, allowing organizations to perform logging and analysis for enhanced visibility and security management. For a complete list of features, visit the URL on your screen. In the next lesson, you will learn how to create and configure Azure Firewall. Application security groups are a powerful way to manage network security for virtual machines in the cloud. They allow you to group virtual network interfaces, or NICs, and apply security policies to those groups, making it easier to secure your applications efficiently. With application security groups, you can define network security rules based on the group rather than individual IP addresses. This means you can reuse your security policies at scale without the hassle of updating long lists of IP addresses. When you assign a NIC to an application security group, the security rules you define for that group automatically apply to the virtual machine connected to that NIC. There are some important limitations to keep in mind. You can define up to 30,000 application security groups per subscription. When creating security rules, you can only specify one application security group as the source and one as the destination. All NICs in a group must be in the same virtual network, and both source and destination groups in a rule must also be within the same virtual network. Application security groups simplify network security management for virtual machines, but understanding their constraints is essential for effective use. Next, you will learn how to create an application security group. Just-in-time provisioning is a security feature designed to lock down inbound traffic to Azure virtual machines. By using just-in-time provisioning, you ensure that only those who truly need access to your virtual machines receive it, and only at the exact moment it is required. This approach is especially effective at protecting against brute force attacks, which often target management ports to gain unauthorized access. When just-in-time provisioning is enabled, the amount of time that these ports are open is strictly limited. This means attackers have a much smaller window to attempt access, significantly reducing the risk of a successful attack and preventing them from establishing a foothold in your environment. Just-in-time virtual machine access not only limits access privileges, but also increases visibility into how privileged accounts are used. To enable this feature, you create a policy specifying which ports to protect, how long they should remain open, and which approved IP addresses can connect. This gives you precise control over user actions during access requests. All access requests are logged in the Azure Activity Log, making monitoring and auditing straightforward. To use just-in-time virtual machine access, you must be on the standard pricing tier of Azure Security Center. Security baselines are essential for protecting your resources in Microsoft Azure. While Microsoft works to make every service secure by default, it is ultimately up to each customer to ensure their environment is properly protected. Azure provides a default security baseline for every service, designed to cover most common scenarios. However, Microsoft does not monitor or respond to incidents within your area of responsibility. This means you must review and adjust these controls to fit your organization's unique needs. Several Azure tools help you build and maintain strong security baselines. The Azure Portal and Azure Resource Manager are used for creating resources and applying access controls. Azure Key Vault encrypts virtual drives, storage, and databases. Azure Active Directory manages identity and access, including hybrid identity services. Azure Policy secures virtual networks, restricts resource types, and enforces geo-regional rules. Azure Security Center and Azure Monitor both detect vulnerabilities and monitor for malicious activity. Because every environment is different, there is no one-size-fits-all approach. Understanding and using these tools allows you to create security baselines tailored to your organization, ensuring your Azure resources remain secure. Managing connectivity with Azure Network Watcher. Network Watcher in Azure offers powerful tools for troubleshooting connections. One of the most useful is IP Flow Verify, which checks if packets are allowed between a virtual machine and an endpoint based on security group rules. To use IP Flow Verify, open the Azure portal and search for Network Watcher. Make sure it is enabled in the region where your resources are located. Then select IP Flow Verify, pick your resource group, and choose the virtual machine you want to test. Next, select the network interface if there are multiple, and choose whether to test TCP or UDP traffic. Decide if you want to check inbound or outbound connections. Enter the remote IP address and the port number you want to test, then click Check. If your virtual machine, or VM, cannot connect to another resource, and you have already used IP Flow Verify to rule out security group issues, it might be time to check for routing problems. That is where Network Watcher comes in. Network Watcher offers a tool called Next Hop to help diagnose routing issues. For example, if you want to test connectivity from MyVM1 to MyVM2, enter the destination address of MyVM2 in the appropriate field. Then set the source back to MyVM1. You do not need to specify a port, since this test checks routing for all ports. Click Next Hop and wait a few seconds for the results. IP Flow Verify quickly tells you if access is allowed or denied and identifies the specific security rule responsible. For example, you might see that the Allow VNet Outbound rule permits the connection, or a custom rule blocks it. Remember, to fully verify connectivity, test both outbound and inbound directions between your virtual machines. IP Flow Verify makes troubleshooting network connections in Azure straightforward, helping you pinpoint security group rules that allow or block traffic in just a few clicks. If your virtual machine, or VM, cannot connect to another resource and you have already used IP Flow Verify to rule out security group issues, it might be time to check for routing problems. That is where Network Watcher comes in. Network Watcher offers a tool called Next Hop to help diagnose routing issues. For example, if you want to test connectivity from MyVM1 to MyVM2, enter the destination address of MyVM2 in the appropriate field. Then set the source back to MyVM1. You do not need to specify a port, since this test checks routing for all ports. Click Next Hop and wait a few seconds for the results. The tool will display the next hop type, such as a virtual network gateway, along with its IP address and the route table ID used to determine the next hop. This information is most useful if you expected a different next hop, as it helps confirm or challenge your routing assumptions. To see the actual route, go to the VM, select Diagnose and Solve Problems, click I can't connect to my VM, and then choose Effective Routes. This shows the route used for the connection. If the next hop matches your expectations but issues persist, consider using Network Watcher's Connection Troubleshoot feature for deeper analysis. If your virtual machine is struggling to connect to an endpoint, and tools like IP Flow Verify and NextHop have not solved the issue, Network Watcher's Connection Troubleshoot tool can help you dig deeper. Before using Connection Troubleshoot, you need to install the Network Watcher Agent extension on the virtual machine experiencing the problem. Go to your VM, select Extensions, click Add, and choose Network Watcher Agent. Once installed, return to Network Watcher to access the Connection Troubleshoot feature. With the tool open, you can test connectivity between your virtual machine and an endpoint. The endpoint can be another VM, a fully qualified domain name, a uniform resource identifier, or an IP address. For example, set your source as myVM1, destination as myVM2, and destination port as 80. Click Check to start the test. The tool provides detailed results, including all hops along the route and latency between source and destination. For instance, an average latency of 5 milliseconds indicates a fast connection. It also reports probe failures, which can help diagnose issues. You can click any point along the route for more details, and the topology view offers a graphical connection path. Remember, sometimes multiple tools are needed to fully diagnose network problems.
If you are having trouble with your virtual private network or VPN connection, the VPN troubleshoot tool can help you get to the root of the problem. This is especially useful for connections between virtual networks or to on-premises locations. To get started, head to the VPN troubleshoot page. Select the resource group that contains your connection, then choose the location. Next, you need to decide where to store the diagnostic data. Click on Storage Account and either pick an existing one or create a new one. After that, select a container for the logs. For example, you might use one called Network Watcher Logs.
The tool will show you a list of gateways and connections in your chosen location. You can select as many as you want to test at once. For this example, let's select 2 gateways, GW1 and GW2, and start troubleshooting. Keep in mind, this process can take a while. Once the test finishes, you will see the health status of each gateway. If a gateway is unhealthy, the tool will explain why. For instance, it might say VPN connectivity is impacted due to disconnected site-to-site VPN tunnels, possibly caused by Internet Key Exchange, or IKE, issues. When your business relies on a critical network connection, constant monitoring is essential. That is where Network Watcher's Connection Monitor comes in. It keeps an eye on connections between virtual machines, or VMs, and endpoints, ensuring your network stays reliable. To get started, click on Connection Monitor, then Add. For example, to monitor the connection between myVM1 and myVM2, name it accordingly. Set the source VM to myVM1 and the destination to myVM2. Choose the port, such as 22 for SSH, and click Add. Remember, you need the Network Watcher extension installed on your VM to use Connection Monitor. Once set up, Connection Monitor displays round-trip latency graphs and the percentage of failed probes. You can view data for the past hour or extend it to 7 days. The tool also shows the route hops between VMs, either in a grid or topology view, similar to the Connection Troubleshoot tool. To get notified about issues, use Azure Monitor. Search for Monitor, go to Alerts, and create a new alert rule. Select your Connection Monitor, add a condition like average round-trip time above 150 milliseconds, and set up an action group to receive notifications. If you are dealing with intermittent networking issues or managing many connections, you need detailed insights. That is where Network Watcher's NSG flow logs come in. These logs track what traffic was allowed or denied by each rule in a network security group, or NSG. To start, open Network Watcher and select NSG flow logs. You will see a list of network security groups, which you can filter by resource group. Click on the NSG you want, switch the status to On, and choose a storage account. Set your retention period. By default, it is 0, meaning logs are kept forever. Adjust this to manage storage costs, for example, to 30 days. Once enabled, logs are stored in your chosen storage account under a container called Insights-Logs-Network Security Group Flow Event. The logs are organized by NSG, date, and the MAC address of the network interface. Each log in JSON format details the rule, timestamp, source and destination IPs, ports, protocol, direction, and whether traffic was allowed or denied. Turn on Traffic Analytics for deeper insights and select or create an OMS workspace. This fine-grained data is invaluable for troubleshooting complex security filtering issues. Traffic Analytics is a powerful tool within Network Watcher, designed to give you a clear, interactive dashboard of your network's activity. It helps you quickly spot trends and drill into the details when needed. When you open Traffic Analytics, you can filter by resource group to focus on specific areas. The dashboard displays overall inbound and outbound traffic, highlighting how much is malicious. Clicking the red bar runs a log search, revealing a list of malicious traffic flows for deeper investigation. The View Map feature offers a global perspective. Active regions appear as green circles. Hovering over a region provides a summary, while clicking reveals detailed traffic flows. Red lines indicate malicious flows, and zooming out shows all countries where threats originate. Clicking for more details brings up a graph of the last 24 hours. Hovering over each hour shows total flows, how many were blocked or allowed, and the number of malicious attempts. Most malicious flows are blocked, but you can see which were allowed. Traffic Analytics highlights which network security group rules are most active. It identifies common attack ports, like port 445 for Microsoft Directory Services, and shows where attacks originate, such as the United States, Thailand, and China. Finally, the dashboard summarizes data on VPN gateways, load balancers, and application gateways, giving you a comprehensive view of your network's security landscape. To manage Azure subscriptions and resource groups effectively, understanding Azure Role-Based Access Control, or RBAC, is essential. Let's break down the most important built-in roles you'll encounter in Azure. The 4 key roles. There are 4 key roles you should know: contributor, owner, reader, and user access administrator. The contributor role grants full access to manage all Azure resources, but cannot assign roles to others. The owner role is similar, but with one crucial difference. It allows the user to assign roles to others, essentially giving them full control over resources. The reader role is straightforward, allowing users to view resources without making changes. Finally, the User Access Administrator manages who can access Azure resources but cannot access the resources themselves. Beyond these, Azure offers dozens of specialized roles. For example, the Virtual Machine Contributor can manage virtual machines without accessing them or their connected networks. There are also roles for networking, storage, web, containers, databases, and more, each tailored to specific resource types. While you do not need to memorize every role, knowing these 4 key roles is vital. And remember, you can create custom roles if built-in options do not meet your needs. Azure Security Center automatically creates a default security policy for every Azure subscription. These policies are essential for maintaining a secure cloud environment and can be edited or monitored for compliance directly within Security Center. Security requirements often differ between development and production resources. That is why it is critical to maintain policies tailored to each environment. Security policies drive recommendations and monitoring, helping to identify vulnerabilities and mitigate threats before they become issues. The default security policy includes a range of definitions. For example, the System Updates policy retrieves daily lists of available security and critical updates, recommending that missing updates be applied. Security configurations policies analyze operating system settings to identify vulnerabilities in virtual machines and suggest configuration changes. Endpoint protection and disk encryption policies recommend ways to protect virtual machines from viruses and data theft. Beyond these core policies, Azure offers additional protections such as network security groups, web application firewalls, next-generation firewalls, SQL auditing and threat detection, SQL encryption, vulnerability assessment, storage encryption, and just-in-time network access. Leveraging these policies helps identify and mitigate potential vulnerabilities across your Azure environment. A resource group in Microsoft Azure acts as a logical container for your cloud resources. Think of it as a way to organize and manage collections of resources like virtual machines, virtual networks, and storage accounts, making provisioning, monitoring, and access control much simpler. One major advantage of using resource groups is cost management. By grouping related resources, you can track and control expenses more effectively. Resource groups also help ensure that resources with a shared purpose or life cycle are managed together. When you create a resource group, Azure requires you to specify a region. This is because deployment metadata and definitions need to be stored in a specific location. However, the resources within that group can be spread across multiple regions, offering flexibility in deployment. To keep your Azure environment organized, it's important to group resources that need to be updated or managed together. For example, all components of a business application that share a lifecycle should be in the same resource group. Separate resource groups for development, staging, and production environments help manage different life cycles efficiently. In upcoming lessons, you'll discover how to manage resource groups using policies, resource locks, and tags, as well as how to move or delete resource groups as your needs evolve.
IT governance is essential for organizations, ensuring that information technology aligns with business goals. By setting clear priorities and planning initiatives strategically, IT governance helps manage resources efficiently and prevents issues before they arise. Azure Policy is a service within Microsoft Azure designed to create, assign, and manage rules for cloud resources. These policies help organizations enforce compliance with corporate standards and service-level agreements, keeping IT operations aligned with business objectives. Azure Policy evaluates both new and existing resources, checking for compliance with defined rules. For example, if a policy only allows certain virtual machine sizes, Azure Policy will enforce this restriction during resource creation, updates, and regular scans. Several built-in policies are available by default. For instance, the SQL Server 12.0 policy ensures all deployed SQL servers use version 12. Other policies restrict storage account sizes, allowed resource types, deployment locations, and virtual machine SKUs. Tagging policies can also enforce or apply required tags to resources. Policies can be assigned through the Azure portal, PowerShell, or Azure command line interface. Azure Policy re-evaluates resources about once every hour, ensuring ongoing compliance even after policy changes. Sometimes protecting your critical resources in Azure means preventing accidental changes or deletions. That is where resource locks come in. By applying locks at the subscription, resource group, or individual resource level, you can safeguard your environment from unintended actions. Azure offers two lock levels, delete and read-only. The delete lock, also known as cannot delete, allows authorized users to read and modify a resource, but not delete it. The read-only lock restricts users to only reading the resource, blocking both deletion and updates. When you apply a lock at a parent scope, such as a resource group, all resources within that group inherit the lock. Even resources added later will automatically receive the lock. If multiple locks exist, the most restrictive lock always takes precedence. Be aware that read-only locks can sometimes cause unexpected issues.
For example, listing storage account keys is blocked because it requires write access, even though it seems like a read operation. Similarly, Visual Studio Server Explorer cannot display files for an app service resource under a read-only lock. To create or delete management locks, you need specific permissions, Microsoft.authorization/star or Microsoft.authorization/locks/all-actions. Only the built-in owner and user access administrator roles have these permissions by default. Applying tags to Azure resources is a powerful way to organize and manage your cloud environment. Tags are made up of a name and a value, letting you create a logical taxonomy for your resources. For example, you might use a tag called environment with the value production. Tags make it easy to retrieve all resources in a subscription that share a specific tag name and value, even if those resources are in different resource groups. This is especially useful for organizing resources for billing and management. By grouping related resources with tags, administrators can streamline operations and reporting across their Azure environment. However, there are some important limitations. Each resource or resource group can have up to 15 tag name and value pairs. Tag names are limited to 512 characters, while tag values are capped at 256 characters. Tags applied to a resource group are not inherited by the resources within it, and classic resources like cloud services cannot be tagged. To apply tags, users need write access to the resource type. The contributor role allows tagging across all resource types, while specific roles like virtual machine contributor limit tagging to certain resources. Sometimes you need to move resources between resource groups in Microsoft Azure. While this is possible, there are important considerations to keep in mind to ensure a smooth and error-free process. When you move resources, both the source and target resource groups are locked for the duration of the operation. This means you cannot add, update, or delete resources in either group until the move is complete. Despite the lock, the resources themselves are not frozen. For example, if you move an application server and its database, the application continues to run without any downtime or interruption. It is important to remember that moving a resource does not change its location. Even if the new resource group is in a different location, the resource itself stays in its original location. Before moving resources, ensure both subscriptions are in the same Azure Active Directory tenant. The destination subscription must be registered for the resource provider. Also, check that the destination subscription's quotas can support the resources you plan to move. Avoid moving more than 800 resources at once, as Resource Manager will fail the operation. For large moves, break them into smaller batches to prevent errors and timeouts. As a course instructor, I often manage dozens of resource groups in Microsoft Azure, each tied to a specific course or lab. Once a course or lab is finished, I delete the entire resource group to keep my Azure subscription organized and free of unused resources. Deleting a resource group in Azure is straightforward. First, navigate to the resource group in the Azure portal. At the top of the page, click the delete icon. You will be prompted to confirm your decision. Once confirmed, the deletion process begins, and all resources within that group are removed as well. It is important to be cautious when deleting a resource group. When you delete a resource group, every resource inside it is permanently deleted. Make sure you no longer need any of the resources before proceeding. The time required to delete a resource group depends on how many resources it contains. An empty group deletes quickly, while a group with hundreds of objects will take longer.
Microsoft Entra ID. Key concepts to understand. Welcome to Microsoft Entra ID. In this quick overview, we will explore what Entra ID is, who uses it, the available licensing options, key features, and some essential terminology. What is Microsoft Entra ID? Microsoft Entra ID is a cloud-based identity and access management service. It enables secure access to external resources like Microsoft 365, the Azure portal, and thousands of software-as-a-service applications, as well as internal resources such as corporate intranet apps. Who uses Entra ID? Administrators use Entra ID to manage access and enforce security, like multi-factor authentication. Developers integrate single sign-on into their apps. Users with Microsoft 365, Office 365, Azure, or Dynamics 365 subscriptions already benefit from Entra ID. Licensing options? Entra ID offers several licensing tiers. The free version covers basics like user management and single sign-on. Premium P1 adds advanced hybrid identity management, while Premium P2 includes risk-based conditional access and privileged identity management. Pay-as-you-go options are available for external identities and permissions management. Key features. Features include application management, self-service password reset, multi-factor authentication, conditional access, device management, domain services, unified identity for hybrid environments, identity governance, identity protection, managed identities, privileged identity management, workload identities, and robust reporting and monitoring. Important terminology. An identity is any entity that can be authenticated. An account is an identity with associated data. A Microsoft Entra account is often called a work or school account. Microsoft Entra Domain Services is a managed domain service from Microsoft Azure designed to simplify IT operations. It provides essential features like domain join, group policy, lightweight directory access protocol, or LDAP, and Kerberos and NTLM authentication, all without managing domain controllers. With Microsoft Entra Domain Services, you can run legacy applications in the cloud, even if they do not support modern authentication. It integrates directly with your existing Entra ID tenant, so users can sign in using their familiar credentials. Group memberships and credentials are automatically synchronized from Entra ID or your on-premises Active Directory environment, ensuring a consistent identity experience. You define a unique namespace for your managed domain, and Azure deploys 2 Windows Server domain controllers, called a replica set, in your chosen region. These controllers are managed, updated, and secured by Azure, so you never have to handle backups or patches. High availability and disaster recovery, multiple domain controllers provide high availability and redundancy. Replica sets can be deployed in different Azure regions, offering geographical disaster recovery for legacy applications if a region goes offline. This ensures your services remain resilient and reliable. Simplified management and takeaways. Microsoft Entra Domain Services eliminates the need to manage, patch, or monitor domain controllers. It streamlines deployment, integrates seamlessly with Entra ID, and delivers high availability, making cloud transitions smoother and reducing IT workload. Deploying Microsoft Entra Domain Services in Azure is a straightforward process, but it is important to follow each step carefully to ensure a successful setup. Let us walk through the key stages together. Starting the deployment. Begin at the Azure portal homepage. Search for Microsoft Entra Domain Services, select it from the results, and click the button to create a new instance. Choose your subscription and select the appropriate resource group for deployment. Domain and SKU selection. Next, specify your domain name. You can use the Help Me Choose link for guidance, especially regarding DNS advice. For this demonstration, the domain is dsssurfcityboats.com. Then, select a SKU, or stock keeping unit. The enterprise SKU is chosen here, but you can compare options for cost and features. Networking and administration. Proceed to networking. Accept the default to create a new virtual network and subnet dedicated to domain services. For administration, manage group membership by adding users to the AAD-DC Administrators Group, which acts as domain admins for the managed domain. Synchronization and final steps. Advance to synchronization settings. Here, all users are synced, rather than just cloud-only accounts. Accept the default security settings, skip tagging, Review your choices and click Create. Confirm the warning about unchangeable settings. After deployment and provisioning, your managed domain is ready for further configuration.
Hybrid identities are essential in today's corporate world, where organizations use both on-premises and cloud-based applications. Microsoft Entra ID provides a unified user identity, enabling secure authentication and authorization for users, no matter where they are located. Provisioning and synchronization. Establishing a hybrid identity relies on two main processes: provisioning and synchronization. Provisioning is about creating, updating, or deleting user accounts based on specific conditions. Synchronization ensures that identity information for users and groups in on-premises systems matches what exists in the cloud, keeping everything up to date. Types of provisioning. There are several types of provisioning. HR-driven provisioning creates user accounts based on data from human resources systems. App provisioning automatically manages user identities and roles in cloud applications. Directory provisioning moves user information from on-premises Active Directory to Entra ID, ensuring seamless access. Key tools for hybrid identity. Microsoft Entra Connect, Entra Cloud Sync, and Microsoft Identity Manager are key tools that support both provisioning and synchronization. Each tool helps organizations manage hybrid identities efficiently, bridging the gap between on-premises and cloud environments. Authentication methods. Hybrid identity scenarios use three authentication methods: password hash synchronization, pass-through authentication, and federation. These methods ensure secure, flexible access for users across all resources. Role-based access control, or RBAC, in Microsoft Entra ID is designed to simplify how you manage user permissions. Instead of assigning permissions one by one, you assign roles based on job functions, making access management more efficient and secure. Core components. There are three main components to understand: roles, role assignments, and scopes. A role is a set of permissions that defines what actions a user can take. Microsoft Entra ID includes built-in roles like Global Administrator or User Administrator, each with specific capabilities. Role assignments connect users or groups to these roles, while scopes determine where those permissions apply, such as across the entire directory or just a specific application. Custom roles and assignments. Sometimes built-in roles do not fit every organization's needs. That is where custom roles come in. You can create a custom role by defining its purpose and selecting the exact permissions required. Assign these roles to users or groups, ensuring they have only the access they need within the defined scope. Best practices. Always follow the principle of least privilege, assigning only the minimum permissions necessary. Regularly review role assignments to keep them aligned with changing job functions, and use Entra ID's auditing tools to monitor for unusual activity. Enterprise Identity Management with Microsoft Entra ID. Microsoft Entra ID Single Sign-On, or SSO, simplifies how users access their applications. With SSO, you only need one set of credentials to sign into multiple software platforms, making your daily workflow much more convenient. SSO Methods Overview. The method you choose for SSO depends on how your application is set up for authentication. Cloud applications, often called software as a service or SaaS applications, typically use federation-based options like OpenID Connect, OAuth, or SAML. Other options include password-based SSO, linked SSO, or disabling SSO entirely. Federation-based SSO. Federation-based SSO allows users to authenticate across different identity providers, enhancing security, reliability, and user experience. Microsoft Entra ID supports SAML 2.0, WS Federation, and OpenID Connect for a seamless SSO experience. Federation is preferred when supported by the application. Password-based and linked SSO streamlines authentication for both cloud and on-premises applications. Choosing the right SSO method depends on your application's setup and hosting location, ensuring secure and efficient access for every user. Introduction to MFA.
Microsoft Entra ID Multi-Factor Authentication, or MFA, is a powerful security feature that protects your accounts by requiring more than just a password during sign-in. It adds an extra layer of defense to keep your information safe. Why MFA matters? Relying only on passwords can leave accounts vulnerable, especially if passwords are weak or compromised. MFA addresses this risk by demanding a second form of identification, making it much harder for attackers to gain unauthorized access to your data. How MFA works? MFA uses two or more authentication methods: something you know, like a password, something you have, such as a trusted device or hardware key, and something you are, like a fingerprint or face scan. This combination greatly increases security.
Verification methods. Users can choose from several verification options, including the Microsoft Authenticator app, Authenticator Lite in Outlook, Windows Hello for Business, FIDO2 security keys, OAuth hardware or software tokens, SMS text messages, and voice calls. Each method offers a unique way to verify your identity. Seamless integration and flexibility. MFA is built directly into the Microsoft Entra ID sign-in process, so there is no need to change your apps or services. Organizations can easily enhance security and protect resources with flexible, user-friendly authentication options.
In this tutorial, you will learn how to enable multi-factor authentication, or MFA, for a specific user in Microsoft Entra ID. Navigating to Per User MFA. Start by opening the All Users pane in Microsoft Entra ID. At the top navigation bar, click on Per User MFA. This action will take you to the Users pane of the multi-factor authentication page, where you can manage MFA settings for individual users. Selecting and enabling MFA4. On the multi-factor authentication page, locate the user you want to enable MFA for and check the box next to their name. After selecting the user, click Enable. A warning will appear, letting you know that you are about to enable MFA for this user. Carefully read the warning, make sure you understand it, and then click Enable Multi-Factor Auth to proceed. Confirmation and completion. If the process is successful, an Update Successful window will appear. Close this window, and you will see that the multi-factor authentication status now shows as enabled for the user. That is all it takes to enable Per User MFA in Microsoft Entra ID. Microsoft Entra External ID is designed to help organizations securely interact with users outside their company. Whether you are working with partners, suppliers, or customers, understanding external identities is key to managing access and collaboration effectively. What are external identities? External identities allow users from outside your organization to access your resources using their existing credentials. These could be corporate, government, or social identities like Google or Facebook. Their identity provider manages their credentials while you control what they can access. B2B collaboration. Business-to-business, or B2B, collaboration lets you invite external users to your Microsoft Entra ID organization as guests. They sign in with their own credentials and can access shared resources, such as Office 365 apps or line of business applications, even if they do not use Microsoft Entra ID themselves. B2B Direct Connect is a newer approach for organizations that both use Microsoft Entra ID without adding users as guests. Users authenticate in their home organization and receive access tokens for shared resources. Azure AD B2C for customers. Azure Active Directory Business to Consumer, or Azure AD B2C, now part of Microsoft Entra External ID, manages customer identities for consumer-facing applications, letting users sign in with familiar accounts like Facebook or Gmail. Microsoft Entra External ID offers flexible, secure ways to collaborate and connect with external users. Inviting a guest user in Microsoft Entra ID is a straightforward process that allows organizations to collaborate securely with external partners. Let's walk through the steps to bring a guest user into your directory. Starting the invitation. Begin at the All Users page within Microsoft Entra ID. Click the New User drop-down menu, Then select Invite an external user. This action opens the Basics tab, where you'll start entering the guest's information. Filling out guest details. On the Basics tab, provide the email address of the person you're inviting. You can also add optional details, like their display name, a custom invitation message, or CC additional recipients. One required field is the Invite Redirect URL. This is where the guest will land after accepting the invite. By default, it's set to the My Applications page, but you can change it if needed. Assignments and Review. After entering the basics, click Properties to add more optional information, such as user type, which defaults to guest. Next, go to Assignments if you want to add the guest to groups or assign roles. Otherwise, proceed to Review plus Invite. Completing the process. On the review page, double-check your settings. If everything looks good, click Invite. The guest, like Jason Jones in our example, will now appear in your user list as a guest and can start collaborating once they accept the invitation. Privileged Identity Management, or PIM, is a Microsoft Entra ID governance service designed to manage, control, and monitor access to your organization's most critical resources. By limiting privileged access, PIM helps reduce security risks and ensures only the right people have elevated permissions. PIM offers just-in-time privileged access, meaning users receive temporary permissions only when needed. Other features include time-bound access with start and end dates, approval requirements for role activation, enforced multi-factor authentication, and regular access reviews. Administrators can also download audit history for compliance and security purposes. Role assignments in PIM are categorized as either eligible or active. Eligible assignments require users to activate their role before use, while active assignments grant immediate access. Assignments can be scoped to specific resources and set for a limited duration or made permanent, supporting the principle of least privilege, as well as those approving activation requests or participating in access reviews. Self-service password reset in Microsoft Entra ID. Microsoft Entra ID's self-service password reset, or SSPR, empowers users to reset or change their passwords without needing help from administrators or the help desk. This feature helps reduce help desk calls and keeps productivity high when users are locked out of their accounts. How SSPR works. To use SSPR, users visit the SSPR portal and must have already registered their authentication methods. When accessing the portal, Microsoft Entra ID checks the user's account, confirms their organization, and verifies where the password is managed. If a user cannot access their account, they can select the Can't Access Your Account link or go directly to the portal. After entering their user ID and passing a CAPTCHA, eligibility for SSPR is verified. Registration and authentication. Users may be required to register for SSPR when signing into applications like Microsoft 365 or the Azure portal. If not forced, users can manually register through the SSPR setup page or the access panel. Administrators can also require users to reconfirm their authentication methods periodically, ensuring information stays accurate. SSPR streamlines password management, reduces help desk volume, and ensures users are always ready to reset their passwords securely and independently. When users are enabled for self-service password reset, or SSPR, they must register at least one authentication method. However, Microsoft recommends registering 2 or more methods for greater flexibility. This way, if one method becomes unavailable, users can still reset their passwords without hassle. Authentication methods. Let us quickly look at the 6 authentication methods available for SSPR. First, the mobile app notification method sends a prompt to an app like Microsoft Authenticator, allowing users to approve or deny the reset. The mobile app code method requires users to enter a time-sensitive code from their app. Email sends a verification code to the user's registered email address. The mobile phone method delivers a code via text message. office phone available for paid subscriptions calls the user's office phone with a code. Lastly, security questions ask users to answer pre-registered questions, though this method is often disabled due to security concerns. Administrators can require either 1 or 2 authentication methods for password resets, depending on organizational policy. Users with an Azure administrator role must use 2 different methods, adding an extra layer of security to protect sensitive systems and data. When you set up self-service password reset in Microsoft Entra ID, you can also enable SSPR notifications. These notifications are optional, but they play a key role in keeping everyone informed about password changes. If you choose to notify users on password reset, anyone who resets their password will get an email alert. This message is sent to both their primary and alternate email addresses stored in Microsoft Entra ID. If neither address is available, the system tries to use the user principal name as an email address. Importantly, only the user who reset their password receives this notification. Admin notification details. There is also an option to notify all administrators when another admin resets their password. For example, if there are 4 administrators and one resets their password, the other 3 will each get an email letting them know. This keeps the admin team aware of password changes among their peers. Email delivery and troubleshooting. Notification emails come from specific addresses depending on your Azure cloud environment. If you are not receiving notifications, Microsoft recommends checking your spam or junk mail settings. While optional, SSPR notifications enhance security and transparency by keeping users and administrators informed about password reset events in Microsoft Entra ID. Integrating self-service password reset, or SSPR, with your on-premises environment is essential for organizations using both Microsoft Entra in the cloud and Active Directory on-premises. Password Writeback bridges these 2 worlds, ensuring seamless password management. How Password Writeback works. When users reset their passwords in the cloud, Password Writeback instantly pushes those changes to your on-premises Active Directory. This is achieved using Microsoft Entra Connect, Microsoft Entra Connect Cloud Sync, or both, depending on your setup. Password Writeback supports hybrid identity scenarios, working alongside password hash synchronization, pass-through authentication, or Active Directory Federation services. Enforcing on-prem policies, a key benefit is that your on-premises password policies always take precedence. If your local rules are stricter or different from the cloud, those rules are enforced, even if you use password hash synchronization or federation. This means password history, complexity, and age requirements from your on-premises Active Directory are always checked during resets. Supported operations and security. Password Writeback supports both voluntary and forced password changes, whether initiated by users or administrators. All communication is outbound over port 443, so there is no need for inbound firewall changes. This ensures secure, real-time password management across your hybrid environment. Managing role-based access control on Azure. Role-based access control, or RBAC, is a powerful way to manage who can do what in Microsoft Azure. It lets organizations assign specific permissions to users or teams, ensuring that everyone only has access to the resources they need. RBAC works through role assignments. Each assignment has 3 parts: the security principle, the role definition, and the scope. The security principle could be a user, group, service principle, or managed identity. The role definition lists what actions are allowed or denied, such as creating virtual machines but not deleting them. The scope determines where these permissions apply. Azure offers several built-in roles. The owner role gives full access and lets you delegate access to others. Contributor also provides full access but cannot delegate. Reader allows users to view resources only. The User Access Administrator can manage access to resources. There are also specialized roles, like Security Admin, who can manage security policies and alerts in Azure Security Center. Scope in Azure RBAC defines how broadly permissions are applied. You can assign roles at the management group, subscription, resource group, or even individual resource level. This flexibility helps organizations tailor access precisely to their needs.
Introduction to Role-Based Access Control. Role-based access control is the foundation for managing who can access resources in Microsoft Azure. It allows you to assign specific permissions to users, ensuring that only the right people have the right level of access to your cloud resources. Navigating access control in Azure. Within the Azure portal, you will find a section called Access Control IAM, which stands for Identity and Access Management. This is available at every level, from management groups and subscriptions to resource groups and individual resources, making it easy to manage permissions. Assigning roles to users. To give someone access, select your resource group and click on Access Control. For example, if Ari needs to manage all virtual machines in a resource group, click Add, then Add Role Assignment. Choose the Virtual Machine Contributor role, search for Ari's name, select it, and save. Verifying and managing role assignments, you can verify Ari's access by searching for his name under Check Access. The Role Assignments tab displays all users and their roles, including inherited permissions. Ari will now appear as a Virtual Machine Contributor for this resource group. Removing access. To remove access, simply select Ari's user and click Remove. In summary, you can easily add, verify, and remove role assignments in Azure, keeping your resources secure and access well managed. The Azure Activity Log is your window into what is happening at the subscription level in Azure. It tracks every operation performed on your resources, giving you a clear picture of changes and actions across your environment. Activity Log Categories. The Activity Log is organized into 8 categories. Administrative logs capture create, update, delete, and action operations, including changes to role-based access control, or RBAC, such as creating or deleting role assignments. Service health and resource health categories record events affecting Azure's overall health and the health of your deployed resources. Alerts show all activated alerts, while autoscale logs document autoscaling events. Recommendations come from Azure Advisor, offering suggestions for optimization. Security logs are generated by Azure Security Center, and policy logs track actions performed by Azure Policy. Retention and export. Keep in mind, the Azure Activity Log only retains records for the last 90 days. If you need to store logs longer for auditing or compliance, you can send them to an Azure Event Hub for integration with your security information and event management application, or archive them in an Azure storage account. RBAC events. For RBAC, the activity log records every change to role assignments or definitions, including creating, updating, or deleting custom roles, ensuring you have a complete audit trail. Sometimes Azure's built-in roles just do not fit your team's unique needs. That is where custom roles for role-based access control, or RBAC, come in. Today, let's walk through creating a custom role using the Azure Cloud Shell and Azure Command Line Interface, or CLI. Creating the custom role. Start by opening the Azure Cloud Shell from the portal or by visiting shell.azure.com. For this demonstration, we are creating a custom role called Virtual Machine Operator. In Visual Studio Code, our custom role template includes several sections. The name is custom to indicate it is a custom role, a description, actions to specify allowed operations, not actions to deny certain permissions, and assignable scope to define where the role applies. Reviewing and applying the role. Once your template is ready, apply the custom role to your subscription. Use the command AZ-role-definition create --role-definition and your file name, such as vmoperator.json. After running the command, return to the Azure portal, select your resource group, and check Access Control under Roles to find your new Virtual Machine Operator role. Updating and deleting the role. If you need to add permissions, simply update your role definition file, save it, and run AZ role definition update,
--role-definition with your file name. When the custom role is no longer needed, delete it using AZ role definition delete name and provide the role's name. Role-based access control, or RBAC, in Azure is essential for managing who can access and modify resources. However, changes to RBAC do not always go as smoothly as planned. Let's explore some common issues you might encounter. Scenario 1. First, if you cannot create a new resource in a resource group, check the access control settings. Make sure the user has the correct role assignment. If the user is assigned a custom role, verify that the role definition actually allows deployment of that specific resource. Scenario 2. Next, if you try to add a role assignment and see an error saying role assignment limit exceeded, remember that each subscription has a limit of 2,000 role assignments. To avoid hitting this cap, assign roles to groups instead of individual users whenever possible. Scenario 3. If you are unable to create or update a custom role, confirm that you have the Microsoft.authorization/role-definition/right permission. Without this permission, you cannot modify custom roles. Scenario 4. When creating a new custom role, you might see an error about the role definition limit exceeded. Each tenant can only have 2,000 custom roles. Scenario 5 and tips. Finally, if changes do not appear immediately, be patient. Sometimes updates take time to reflect. Logging out and back in can help refresh the portal or console. Configuring Azure Monitor metrics, logs, and alerts. After deploying resources in Microsoft Azure, like virtual machines or storage accounts, monitoring their health and performance is essential. Azure Monitor is the tool designed to automate this process, helping you catch issues early and optimize your resources. Metrics and logs. Azure Monitor automatically collects metrics, which are numeric data points such as used capacity or transaction counts. These are stored in a metrics database. It also collects logs, which are text-based records of events like errors. The activity log, created by default, tracks subscription-level events for up to 90 days at no cost. Setting up log analytics, you can send logs to a log analytics workspace, part of Azure Monitor Logs. This allows you to store logs for up to 12 years and run advanced queries. To do this, create a workspace, configure diagnostic settings for your storage account, and select which operations and metrics to track. Analyzing logs and queries. With Log Analytics, you can write queries to find common errors, such as container not found or blob not found, and analyze trends over time. Microsoft provides example queries to help you get started. Workbooks and visualization. Finally, you can visualize both metrics and log query results in customizable workbooks, making it easy to monitor and share insights about your Azure resources. Monitoring virtual machines in Azure is more involved than with other resources because VMs generate data at multiple levels: the VM itself, the operating system, and the applications running inside. Core monitoring concepts. To collect all this information in Azure Monitor, you need to install monitoring agents on your virtual machine. Without an agent, you only get basic metrics like CPU, disk, and uptime. For deeper insights, such as operating system logs, you must enable additional monitoring features, which may incur extra charges. Agent options and setup. Azure offers two main agents: the Azure Monitor agent, which is now preferred, and the Log Analytics agent, which will eventually be retired. When you enable monitoring, a default data collection rule is created, gathering guest operating system performance data. If you want to map application dependencies across VMs, you can enable the dependency agent. For even more diagnostics, like crash dumps or boot diagnostics, install the Azure Diagnostics agent, though it will also be replaced by the Azure Monitor agent in the future. Diagnostics agent, though it will also be replaced by the Azure Monitor agent in the future. Additional monitoring features. For custom application monitoring, install the Application Insights agent. Windows VMs collect event logs by default, while Linux VMs can be configured to send syslog entries. In summary, Azure VM monitoring relies on several agents, each designed to capture specific data, helping you keep your virtual machines healthy and secure.
Managing Azure costs?
Thinking about moving your IT workloads from an on-premises data center to Microsoft Azure? Comparing costs can be overwhelming, but Microsoft's Total Cost of Ownership Calculator, or TCO calculator, makes it much easier to estimate and compare expenses. Defining workloads. Start by defining your workloads. The TCO calculator organizes these into 4 categories: servers, databases, storage, and networking. For example, you might enter 20 Windows-based web servers running on Hyper-V, 2 physical SQL servers, and 1 terabyte of storage. The tool lets you specify details like the number of virtual machines, cores, and memory. Adjusting assumptions. Next, adjust the calculator's assumptions to match your real-world costs. You can change the currency, electricity rates, and IT labor costs. If you have Microsoft Software Assurance for your Windows or SQL Server licenses, you can indicate that to reduce your projected Azure costs. Viewing the report. Finally, view your report. The TCO calculator compares your current on-premises costs with projected Azure costs over 1 to 5 years. You can see a detailed breakdown and adjust the time frame to see how your potential savings change. Key takeaways. With the TCO calculator, you can make informed decisions about migrating to Azure, ensuring you understand both the costs and the savings before making the move. Introduction to Azure subscriptions. Before you can use Microsoft Azure, you need a subscription. This is how Microsoft tracks and bills for every resource you create. While you can have multiple subscriptions, each Azure resource is assigned to just one subscription. Billing accounts and organization. To actually pay for your Azure usage, you need a billing account. This holds your payment details, like your credit card. You can link multiple subscriptions to a single billing account, which is useful for organizing costs by department or project. Types of Azure subscriptions. There are 3 main types of Azure subscriptions: free, pay-as-you-go, and member offers. The free trial gives you a $200 credit for 30 days and access to certain services for 12 months. After the trial, you must upgrade to pay-as-you-go, which charges you monthly for what you use. Member offers, like those for Visual Studio subscribers, provide discounts if you qualify. Purchasing options. You can buy Azure subscriptions directly from the website, through a negotiated enterprise agreement for large organizations, or via a cloud solution provider, or CSP, which bundles Azure with custom solutions and support. Third-party solutions and marketplace. Once you have a subscription, you can purchase third-party solutions from the Azure Marketplace, including offerings from vendors like Oracle and Red Hat. If you want to estimate the cost of running a service on Microsoft Azure, the Azure Pricing Calculator is your go-to tool. Unlike the Total Cost of Ownership Calculator, which focuses on migration savings, the Pricing Calculator helps you figure out the cost of any specific Azure service. Selecting a service. Let's say you want to launch a website using Azure App Service. Start by heading to the Pricing Calculator and selecting App Service. You can also type the product's name for a quicker search. Each service has its own set of options you'll need to configure. Configuring options. For App Service, you'll choose the region, operating system, and tier. Remember, prices vary by region and operating system. If you're unsure about tiers, the information bubble offers guidance, but for more details, check the documentation. Next, select the instance type, number of instances, and hours. The default is 730 hours, which is the average number of hours in a month. You can also set SSL connections. SNI SSL connections are free. Reviewing the estimate. Once your options are set, you'll see an estimated monthly cost. Keep in mind, this is just an estimate, but it's usually close to the actual cost. adding more services and exporting. You can add more Azure services to your estimate, and the calculator will total everything for you. When finished, export, save, or share your estimate easily. Region and data transfer costs. When estimating Azure costs, the region you choose matters. Hosting resources in Brazil, for example, can be twice as expensive as in the United States. If network latency or data residency is not critical, consider cheaper regions. Also, data ingress is free, but egress, especially across regions or outside Azure, often incurs charges. Grouping resources in the same region helps minimize costs. Reserved capacity and hybrid benefit. You can save by purchasing reserved capacity for services like virtual machines. Committing to a 1-year or 3-year term can save up to 72%. If you have existing Windows Server or SQL Server licenses covered by Microsoft Software Assurance, the Azure Hybrid benefit lets you move those licenses to Azure, reducing costs on virtual machines and databases. Spot virtual machines and resizing up to 90% savings, but they can be removed with just 30 seconds notice. Use them for non-critical tasks like batch processing or testing. Additionally, resizing underutilized virtual machines to smaller, cheaper options can further cut expenses. Azure Advisor's Cost tab highlights savings opportunities, including underutilized or unused resources. Remember, stopped virtual machines may still incur charges for attached disks or public IP addresses. Always delete unused resources separately to avoid unnecessary costs. Introduction to Azure Cost Management. If you want to take control of your cloud spending, Azure Cost Management is the tool to use. It offers 4 main features: cost analysis, budgets, alerts, and recommendations, helping you manage and optimize your Azure expenses. Cost Analysis Module. The Cost Analysis module lets you dive deep into your spending. You can break down costs by service, region, or subscription, and track changes daily or monthly. Visual charts and tables make it easy to spot trends, and you even get a forecast of your projected spending for the rest of the month. Budgets and alerts. Instead of checking costs every day, you can set up a monthly budget and create alerts. For example, you might get an email when you reach 75, 90, or 100% of your budget. You can also set alerts based on forecasts, though this may lead to more notifications if your usage fluctuates. Organizational structure for cost tracking. Azure supports management groups, subscriptions, and resource groups, making it easy for larger organizations to track costs separately. You can set budgets and alerts at any level, from an entire department down to a single resource group. Using tags for cost tracking. Tags let you group related resources together, so you can see the total cost for all resources with the same tag in Azure Cost Management. Implementing Azure Backup. Introduction to Azure Backup. Azure Backup is Microsoft's cloud-based backup solution designed for simplicity and flexibility. With Azure Backup, there is no need for additional infrastructure, making it easy to get started without upfront costs. You can perform both one-off and scheduled backups, all managed through customizable backup policies that fit your organization's needs. What Azure Backup can protect? Azure Backup supports a wide range of workloads. You can protect Azure virtual machines, Azure managed disks, SQL Server running in Azure virtual machines, and SAP HANA databases in Azure virtual machines. Additionally, Azure Backup can safeguard Azure file shares, Azure blobs, and even on-premises files, folders, and system state. This versatility ensures that your critical data, whether in the cloud or on-premises, is always protected. Key benefits and management. As a zero infrastructure solution, Azure Backup eliminates capital expenditures and streamlines your backup process. Its single pane of glass interface allows you to discover, govern, monitor, and manage all your backups directly from the backup portal, making data protection straightforward and efficient. Azure Backup is Microsoft's cloud-based solution for protecting your data, machine states, and workloads whether they run on-premises or in Azure virtual machines. It organizes and secures your backups using specialized vaults in the cloud. Core components. Azure Backup is built on 3 main layers. The workload integration layer connects your backup extension to the workload being protected. The data plane manages where your backups are stored and how they are secured, including access tiers and redundancy. The management plane is where you interact with your backups using tools like Recovery Services Vaults, Backup Vaults, and the Backup Center. Storage and redundancy. When storing backups, you can choose between different access tiers: Snapshot, Standard, and Archive. For redundancy, options include locally redundant storage, or LRS, geo-redundant storage, or GRS, and zone redundant storage, or ZRS. Recovery Services Vaults use geo-redundant storage by default, protecting your data from regional outages. Backup process. Backups from on-premises Windows machines use the Microsoft Azure Recovery Services Agent, or MARS agent, or backup servers like Data Protection Manager. Azure VMs use a backup extension for full or file-level backups. Supported backups. Azure Backup supports full, incremental, differential, and transaction log backups, ensuring flexibility and efficiency for your data protection needs. Introduction to Azure Backup Center. Azure Backup Center is your centralized hub for managing backups across large and distributed Azure environments. Designed as a single pane of glass, it streamlines backup management for organizations with complex cloud infrastructures, making it easier to protect critical data at scale. Key features and use cases. With Azure Backup Center, you can oversee backups for a wide range of workload types, vaults, subscriptions, regions, and even Azure Lighthouse tenants. Its data source-centric design means you can filter and view backup information based on specific data sources. For example, if you use resource tags in your Azure environment, you can filter your view to focus only on resources with a particular tag, helping you cut through the noise and focus on what matters most. Supported resource backups. It is important to note that Backup Center supports specific resource backups. These include Azure Virtual Machine Backups, SQL in Azure Virtual Machine Backups, SAP HANA in Azure Virtual Machine Backups, Azure Files, Azure Blobs, Azure Managed Disks, and Azure Database for Postgres Server backups. Navigating the Backup Center. When you open Backup Center, the overview page displays backup jobs, instances, and active alerts. The Jobs tab summarizes all backup and restore jobs from the past 24 hours, while the Backup Instances tile provides details on configured backup instances. Managing and monitoring backups. The Alerts pane highlights important notifications, and the left navigation lets you manage backup instances, vaults, policies, and compliance settings, ensuring your backups are always under control. What are backup policies? Backup policies are essential for managing ongoing backups in Azure. Just like with other backup solutions, these policies determine how and when your data is protected. They are a core part of Azure Backup, ensuring your resources are regularly and reliably backed up. Where are backup policies applied? You can create backup policies for a variety of Azure resources, including Azure Virtual Machines, SQL in Azure Virtual Machines, SAP HANA in Azure Virtual Machines, and Azure File Shares. If you want to back up files and folders using the Microsoft Azure Recovery Services Agent, or MARS agent, you'll set the policy directly in the MARS console. Configuring backup policies. Backup policies are created on a per-vault basis, and each policy can be assigned to multiple resources. When setting up a backup policy, you'll configure both the schedule and retention settings. The schedule determines when backups occur, either daily or weekly at a specific time. Retention settings define how long backups are kept, with options for daily, weekly, monthly, and yearly retention. Monthly and yearly retention is known as long-term retention, or LTR. Default policies and next steps. When you create a Recovery Services Vault, Azure automatically generates a default backup policy. You can use this default policy or create your own to fit your needs. In the next lesson, you'll learn how to create a backup policy step by step. Preparing for disaster with Azure Site Recovery. If your application is running on Azure and the server crashes, redundancy keeps it alive. But what if an entire Azure region goes offline? That is where Azure Site Recovery steps in to ensure your application's uptime. Why Azure Site Recovery? Azure Site Recovery is designed for rapid disaster recovery. Unlike Azure Backup, which can be slow to restore, Site Recovery quickly fails over all application components to another location. It works for both Azure and on-premises servers, supporting VMware, Hyper-V, and physical servers. How Azure Site Recovery works. Site Recovery supports three main scenarios: Azure to Azure, on-premises to Azure, and on-premises to a secondary site. For Azure to Azure, you replicate virtual machines from one region to another, ensuring business continuity even during regional outages.
Setting up Recovery Services Vault. Start by creating a Recovery Services Vault in a different region from your primary virtual machines. For example, if your VMs are in West US, create the vault in East US. This vault stores backups and manages site recovery. Replication and failover. Enable replication for your virtual machines, set your replication policy, and group VMs for consistency. Once protected, you can run test failovers to ensure everything works, keeping your applications resilient and always available.
Let's walk through a test failover procedure, moving resources from the West United States region to the East United States region. This process ensures your disaster recovery plan is ready when you need it most. Creating a recovery plan. Start by navigating to the Manage menu and selecting Recovery Plans. Click to add a new plan, give it a name, and specify your source and target regions. Next, select the virtual machines you want to include, confirm your choices, and create the plan. Testing the failover. Open your recovery plan and click Test Failover. You'll need to choose a recovery point. In a real outage, you have several options, each affecting how much data you might lose and how quickly you can recover. Understanding RPO and RTO. Recovery Point Objective, or RPO, is the maximum time data can be lost. Recovery Time Objective, or RTO, is the maximum downtime allowed. These two often conflict. A lower RPO means less data loss, but can increase recovery time. Choosing a recovery point. You can select the latest processed, or latest app-consistent recovery point, depending on your needs and replication policy settings. After testing, verify the failover virtual machines, then select Cleanup Test Failover to remove the test resources. When disaster strikes, being prepared is crucial. Azure Site Recovery offers a streamlined way to keep your virtual machines, or VMs, safe and operational. Let's walk through the essential steps for a real failover using Azure Site Recovery. Real failover process. To begin a real failover, simply click the Failover button. This process closely mirrors a test failover, so if you have practiced before, you will find it familiar. The key difference is that after a real failover, you do not want to run a cleanup operation that would delete your new VMs. Instead, you need to ensure your new VMs are running smoothly. Committing and protecting VMs are operating properly, commit the recovery point. This step removes all other recovery points, locking in your current state. Since these VMs are now your production machines, it is vital to start backing them up as soon as your primary region is available again. Click Reprotect to begin this process and ensure ongoing protection. Failing back and final steps. When the status changes to Protected, you can fail back to the primary region by clicking Failover again, reversing the direction. After confirming everything is running smoothly, reprotect your VMs so backups resume to the secondary region. That's how you prepare for disaster with Azure Site Recovery. Thanks for watching. If you haven't subscribed to our YouTube channel yet, we'd love for you to join our growing community. Just hit that subscribe button.